T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up.
Greetings, everybody, wherever you may be, and welcome to Kourou, the home of Ariane, for tonight's live broadcast of Ariane spaceflight number 160. We're coming to you live from the Jupiter Mission Control Center, where, as you can see, the crews are at their posts, monitoring the final moments of Final Countdown.
Tonight's French commentators will be Pierre Junier and Philippe Roland, and in English, myself, Michael Caleri, with Joshua Jampol. You can follow tonight's launch and get all the latest Arianespace news and information on www.arianespace.com.
The clock is ticking. We're moving forward just as we should be for tonight's launch of Ariane spaceflight number 160. Nice shots of the launcher on the pad. With me, Mike Caleri, Program Director with Arianespace. Good evening.
Good evening, Joshua. I'd like to say good evening also to my colleagues in Every, Singapore, Tokyo, Washington, and good evening to my friends and family watching on the Arianespace website.
You probably know we were supposed to go last night. We're going with a 24-hour delay. Can we get an explanation of that, please?
Yes, basically yesterday during the final procedure for the satellite, one of the satellites saw some data that they didn't quite understand and needed some extra time to check out and verify.
But all is go. They found what they were looking for, apparently.
Correct, all is go, everything is green, and we move ahead.
We're on our way. Looking down into the Flight Directorate, Arianespace Top Management, the Chief Jean-Yves Le Gall. We're going now to an interview with him for the latest on Ariane.
This is the first flight for Ariane 5 tonight with the orbiting of INSAT 3A for the Indian agency, ISRO, and the orbiting of Galaxy 12 for the US operator Panamsat. First flight in quite a heavy year, since we will have 4 other flights Ariane 5 this year, normally in June, in August, in October, in December. And then in 2004 we will have new flights of Ariane 5 ECA since what happened in December. Our teams have worked hard, really hard, and today we will start again with flights. So there is a very heavy program, a very ambitious program, but I'm sure that we will be very successful in the year 2003, and at the beginning of 2004 we will start again, and it will be a new start for Arianespace.
So there's the word for this year and next year, a string of Arianes ready to go. Very busy period for us all. Tonight's launch, a very international flight, a satellite for the Americans and for the Indians. And our video broadcast will bring you all of the events. Take a look at the summary of that video.
Power. Liftoff.
Some of the highlights of our broadcast you'll be watching tonight include interviews with some of the major participants on the launch teams responsible for the mission. We'll also be bringing you some of the latest news from the Arianespace Company.
We'll also have a summary from the 2 satellites for Flight 160, INSAT 3A and Galaxy 12, along with interviews with the key players from both programs.
And, of course, all leading up to the main event, liftoff, just a quarter of an hour away. 15 minutes and 17 seconds away, to be exact. You see on the left the green status panel summarizing the go or no-go situation on all the systems and operations across the base. Michael?
Yes, as Joshua said, we have the status board that shows the systems on the launch base, the launcher, and of course the 2 satellites.
Looking now at the payload managers for Ariane Space who deal with the customers, this is your job.
That's my job. That's my colleague, Christophe Bardou and Jean-François Lemonnier.
They are the customer interface for Ariane.
And there's Remy Cochet, the Ariane Space mission director, responsible for coordinating the launch campaign for the satellites.
Remy Cochet, his 24th mission tonight as the mission director. He's the dean. He's done the most. We're going to go now to a look, an explanation of tonight's Ariane mission.
For tonight's mission, an Ariane 5 generic launch vehicle will be used. The mass at liftoff is about 750 tons with a total thrust of 1,200 tons. The solid rocket boosters supply more than 90% of the thrust during the first part of the flight and are separated approximately 2 minutes and 20 seconds after liftoff. The launcher continues to the geostationary transfer orbit with an apogee of 35,786 kilometers and a perigee of 860 kilometers. INSAT 3A weighs 2,950 kilograms and was built by ISRO. Galaxy 12, built by Orbital Sciences for PanAmSat, weighs 1,790 kilograms. The launch window duration is 41 minutes from 22:49 to 23:30 Universal Time.
Good shot of the launcher on the pad. For those of you not familiar with the Ariane 5, she is basically in 2 parts. They call them composites, a lower composite and an upper.
Yes, we have the 2 stages, as we like to say. The first stage is a cryogenic stage with the Vulcan 1 engine and the 2 solid rocket boosters. And the upper stage, or second stage, is a storable propellant stage that includes also the fairing, the 2 satellites, and other equipment in the upper stage.
All activities and operations relating to the launcher at liftoff and before are dealt with by the Launch Control Center and the crews teams up there, about 100 or 200 people. We're going to go up now to visit the CDL, as it's called, and you'll be speaking to the man in charge, André Sicard.
We are in the Ariane 5 control room in Launch Control Center number 3. It is here that the launcher team controls the preparation of the launcher into flight configuration for the final countdown. This command console is connected to a series of computers that can in turn communicate with other computers located in the launch table at the launch zone. Of course, all the people in this room today participated in the Flight 160 launch vehicle campaign. The launcher campaign L514, Flight 160, Ariane 5 generic, took place in 2 phases. The first phase started the 20th of January and ended in mid-February, during which the different stages of the launcher were integrated and also the electrical and fluid controls were made. The start of the second phase began on March 20th. The first week included complementary work, of which the most important was the integration of the flight nozzle onto the Vulcan 1 motor. Next, the launcher was transferred from the launch integration building to the final assembly building, where the standard planning was completed in parallel to the combined operations for the 2 satellites for this launch, INSAT 3A and Galaxy 12.
Well, now you know all about the launcher campaign, but that's just half the story. The satellites also have their own campaigns when they come to Kourou. And up next, a short film to see how they were readied. The launch campaign for the 2 satellites for Flight 160, INSAT 3A and Galaxy 12, started in January. This began with their electrical testing, which lasted about a week. Afterwards, INSAT performed the solar array deployment tests, and the antenna deployment. Next, the two satellites underwent the propellant loading operations here in the S5 building. And after a short interruption, the two satellites were transferred here to the final assembly building. The two satellite launch campaigns went very smoothly with no problems at all. Remember now that INSAT 3A will be launched in the upper position on tonight's dual launch carrying structure, and Galaxy 12 will be inside the carrying structure, which is called the Silda.
Okay, back in Jupiter, we have Dr. Rajan Khan, the Satellite Mission Director for INSAT 3A from ISRO. And he is next to his team in the front area there, and we'll also see Rick Laurie from PanAmSat, the Satellite Mission Director for Galaxy 12. And these two men interface directly with the Ariane Space Mission Director, Remy Cochet, during the launch campaign.
Both passengers tonight, old and loyal friends and customers. This is the 10th launch for ISRO. Relationship between Ariane and ISRO goes back to 1981. And the 16th launch for PanAmSat and Galaxy. We are going to go now, as you can see, we're all green. We're going to go back to the latest news
Red.
from Ariane Space.
L'arrêt des comptes programmé est confirmé. Le temps des comptes s'arrêtera à H0 moins 7 minutes.
Just after his appointment as president of the French National Space Agency, CNES, Mr. Yannick Descatha made his first visit to Kourou. On March 10th, he visited the CSG with Ariane Space Chief Executive Jean-Yves Le Gall and got a close-up look at the Ariane 5 facilities, including tonight's launch vehicle.
The Mars Express spacecraft has arrived in Baikonur for the start of the launch campaign. Mars Express is the first European mission to go to Mars. It consists of an orbiter and lander called Beagle 2. The Mars Express launch is scheduled for June 6 on a Soyuz frigate launcher for Starsem.
A tree planting ceremony was held this afternoon in front of the Jupiter Mission Control Building for two of the cities participating in the Community of Ariane Cities program. Two royal palms were planted, one for Bordeaux in France and the other for Colleferro in Italy. Coming down to the 7-minute mark, you see Ensemble de Lancement on the top of the screen, a red. The 7-minute mark is normally when the automatic or synchronized sequence, as it is called, begins, which is when the computers take over. But tonight we have a little something special. Michael?
Yes, tonight we have in this countdown a planned red. So this red is not a surprise to any of the launcher teams, base teams, or satellite teams. And we've had to do this to prepare. Well, we will stop, first of all, at the H-7 point. The clock will stop. And as Joshua said, that is the point where we normally start the synchronized sequence. And Remy Cochet will have a brief introduction and explanation of this red, this planned hold red.
À tous de l'EDO. Arrêt des comptes programmé pour ajustement du niveau dans le réservoir d'oxygène liquide du premier étage. Tous les moyens se tiennent prêts pour une reprise de la chronologie sur très court préavis.
So, as Pierre Ribardier said, this is a planned hold to make some last-minute calculations on the amount
Durée estimée de l'arrêt chronologique 3 minutes.
So he said that we're going to hold probably for 3 minutes. This is planned, as we said, and it's not an unforeseen incident. And we have a short interview with Remy Cochet, whom you saw on the screen earlier, to explain precisely why we are moving into this sort of a situation. Remy? Remy, we've moved into now what we call the built-in hold or a programmed red. Why do we have to do that?
Well, we have to do that because of the specific tuning of this engine for this flight. We have to offload 1,070 kilos of oxygen in the oxygen tank. This represents just a few millimeters of
Reprise dans 2 minutes environ.
tank level. But to do that, we need to do this operation during the topping phase, which is the last phase before the automatic liftoff sequence. We have to adjust actually the topping sequence with the liftoff time. That means that somewhere we have to have a hold. And this hold is programmed at -7 minutes before the automatic liftoff sequence. In the flights before, we had tuning which was a standard tuning for all the launches that we did not need to offload oxygen, but for this specific tuning we need to offload. The maximum duration can be 16 minutes and 30 seconds, and at a minimum, let's say 3 minutes 4 minutes.
Between 3 minutes and 16 minutes, that's quite a big jump now. Why is that?
Because the actual topping cycle is exactly 16 minutes and 30 seconds, and we have a very precise moment in this cycle where we can resume the countdown.
While you were watching the interview with Remy Cochet, you can see we're still red. We heard an announcement that the red hold will last for about another 2 minutes or something. So it seems, Michael, that they have it pretty much down to precise figures.
Yes, as Remy said, the duration was expected between 3 to 16 minutes, and since this was planned, the engineers knew what to look for, what to do, what to calculate, and we got it done on the quick side, so very good for the teams at the CDL.
Now, we have a launch window which was, I believe, 41 minutes long.
Yeah, correct, right? 41 minutes.
We haven't eaten too much into that window.
No, if we stay as planned.
À tous de l'EDO, attention pour la reprise immédiate du décompte.
Didio has just said,
7,
stand by
6, 5,
for
4,
recommencement of the
2,
countdown.
unité, top.
So we're back off and running. That was...
À tous de l'EDO, début de la séquence synchronisée de lancement. Le nouveau H0 visé est 22 heures, 52 minutes, 19 secondes en temps universel.
Okay, so that was a very short hold. The crews, as Michael said, found what they were looking for. The top-up has been completed, and we have moved into the automatic sequence.
Yes, the synchronized sequence is when the computers take over the final checks of all the systems on the launcher, on the ground, because there's thousands and thousands of data points that have to be looked very quickly at this time, and it's necessary for the computers to take a look.
We'll have more on the synchronized sequence, but we're going to go to a couple of films coming up on the sponsors for tonight's launch. We have two participating cities, Bordeaux and Colleferro, as you know. And these are part of the Ariane Cities, participating Ariane Cities Association. You can see they are sponsoring the launch, Colleferro in Italy, outside Rome, and Bordeaux. They get their names on the logo. The Community of Ariane Cities is a non-profit organization which promotes Europe's space transport activities and research. Roughly 30 members cities, including Évry and Cayenne, and of course Bordeaux and Colleferro. The last city to sponsor the flight, by the way, was Charleroi in Belgium. That was Flight 153 last July, and on that flight went up an orbital-built satellite.
N-Star C. Correct. So we're back in Jupiter. All is green. The satellite teams, you see Galaxy and Insat looking, waiting for the liftoff in the next 5 minutes.
The synchronized sequence continuing, counting out. Nice shot of the launcher. That camera is posed on one of the very large flame ducts that will take the fumes from Ariane as she lifts off the pad. You'll see that. The synchronized sequence has to be done because it is, any launch, of course, a very complex affair. You can see the map. You see where Kourou is. The weather tonight, no clouds over Kourou by this map. We should have clear skies. We'll see. The clouds came over a little bit earlier in the day, but we should have a very fine launch and some spectacular pictures for the people who park with their video cameras along the beaches here. We'll know that in just 4 short minutes.
Again, all is green as the countdown continues. The computer's doing the final checks. Every system being checked prior to the liftoff.
What is happening basically during the synchronized sequence is the computers are checking the systems, as Michael said. There are 2 computers. One checks the electrical systems and one checks the fluids. And these computers are located up in the CDL, the Launch Control Center, which we visited a little earlier. They are checking out the 1,000,001 operations, too many for human humans to do, I
and
imagine.
this is, at this point, it's still on, it's checking out the launcher and the ground systems. And of course, we have to remember the satellites too. They're in their final countdown procedure also. Both satellites are on internal power, ready for launch, just waiting for the last 3.5 minutes.
Some of the operations checked out by these computers include the final arming of the what they call more hazardous units, like the pyrotechnic cords, which will be responsible for stage separation. We'll get back to that with an explanation as they happen. The computers are also loading the exact ignition time into the onboard computers, which are located in the upper stage of Ariane. So generally, power is passing from the ground to the launcher as she becomes autonomous.
Correct. We're going to go to now a little film of the rollout of the launcher, which occurred Monday around noontime. What we know here is we're at minus 2 minutes and 40 seconds, but the countdown started Monday morning at 6 a.m. to prepare for the transfer of the launcher from the final assembly building to the launch zone. And we did have to wait 1 day for the satellite to make its final checks, but here we see the transfer and the arrival at the launch zone.
As you can see from the launch zone, from the final assembly building, I should say, to the launch zone, the launcher rides on its table along a rail track, a distance of about, what, a kilometer?
About a kilometer, takes about 40 minutes. And back in Jupiter, 2 minutes, all is green.
2-minute mark. Michael, you spend most of your time down in the fishbowl with the customers. At the 2-minute mark with your customers, how would you describe the atmosphere at this point with the satellites ready to go?
The satellites, yes, are ready to go, but everyone there is now, there's obviously excitement waiting for the liftoff, anticipation, but still a concentrated focus that there still is a job to do prior to the liftoff.
Coming up on the 1-minute mark now, a minute and 30 seconds, you'll hear the DDO call out that 1-minute mark. As Ariane waiting on the pad, second launch of the year, the 10th for our Indian friends and the 16th for PanAmSat, flight 160.
À tous de DDO. Attention pour H-1 minute.
The DDO will call out that 1-minute mark.
Top. H-1 minute et décompte.
And we are into the final 60 seconds here with Ariane Space Flight number 160. Remember, you can follow it all on the website. We want to give you a quick rundown of the final ignition sequence. You will see the engines light, but you won't see Ariane liftoff right away.
Correct. It H0, we call the liftoff point. The Vulcan 1 main engine is ignited and checked out for approximately 6 seconds, all the necessary parameters, thrust, etc. And after all of that checks out positively, the solid rocket boosters are ignited, and that's when we'll leave the launch table.
All right, and we will leave you to listen to the DDO call out the final 10 seconds, and we'll be back with you once Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final.
Enjoy the liftoff.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Décollage.
Well, Ariane is off and running. You didn't see her get too far because of the clouds. She went right up into the clouds. But at least at liftoff, you saw the enormous amount of light
Tous les paramètres à bord sont normaux et la trajectoire est normale.
that she creates. The DDO is saying that everything is normal. On the left-hand side of your screen, on the upper part, you have the cursor climbing up the graph there. There are two paths. One is the nominal trajectory, the noise from Ariane just coming over here from 13 kilometers away. The superimposed upon that is the real time. So as long as we're pretty much Together we are doing fine. Michael, on the lower left,
Yeah, the lower left, we have the T, which is the time after liftoff. The moyenne is the inertial unit sending the data. And then we have the elevation, altitude, and velocity. And we do see a picture now. There are some clear skies to see the lights of the Ariane 5.
actually she's coming back. You didn't see it on this camera, but Ariane rises for about 5 seconds and then tilts over. The mass at liftoff was, everything is normal on board, is the DDO, is what he's saying. There's 750 tons on liftoff. Burning are 3 engines, the Vulcan one, that's the main engine in the middle, and the 2 EAPs, that's the solid boosters, on the sides. The boosters each 600 tons of propellant. You see on the cursor on the upper left, crawling up to that mark which says SEP EAP. I don't know if you can read that, very small letters, but that's separation of the boosters. You'll hear the DDO call that out.
Séparation des étages accélérateur à poudre.
There we have it, separation of the solids, and we're now in flight using the Vulcan 1 engine. Everything is normal.
The boosters are jettisoned and they fall back into the Atlantic. Michael, are they ever recovered? Are they ever reused?
They can be recovered. For this mission, we are not doing the recovery operation. Reuse, no. When we do the recovery, it's just to do an evaluation to check the burn.
On the upper left again, the cursor crawling up to the next point, which says SEPQUAF, which means separation of the fairing, which is the next milestone. You'll hear the DDO call that out as well. You can see on the lower left our speed to...
Largage de la coiffe.
There's the fairing jettison.
So now we've exited the Earth's atmosphere, and that's why we're allowed to separate the fairing at this point. Because of the space environment, there's no risk to the satellite in the upper position.
The fairing halves, you saw, are jettisoned by a process of pyrotechnic cords, and we'll get back to that for an explanation maybe when we have the separation of the EPC.
Okay.
For now, we're burning only on the EPC, which is the core stage. Our speed, as you can see, is almost 2.5 kilometers per second. How fast do we have to go to
We'll be
deliver the
looking
satellites?
for velocity a little under 9 kilometers per second, so we still have a way to go.
So watch the numbers, folks. When you see little under 9, then you know that we're approaching separation. Meanwhile, all is go on board. All the propulsions, all the systems, all the trajectory. We are doing fine. You're watching Arianespace flight number 160, and remember, you can follow us on the website, arianespace.com.
Correct, and this burn will last for another 5.5 minutes, approximately half the mission time.
The first half of the mission carried out by the core stage and the boosters. We're going to go now to the first of our films on our sponsoring cities. Coming up, Bordeaux.
Bordeaux Metropole, 660,000 inhabitants, 35,000 hectares, a quality of life like nowhere else, a sense of equilibrium that successfully combines economic development and respect for the environment, performance and lifestyle, with both the inheritance of the past and a vision for the future. Internationally renowned for the quality of its wine, Bordeaux Metropole has a tradition of exchanges with the world. Its reputation owes also much to its intense cultural life and a strong sense for celebration. With high potential in terms of R&D in high-level universities, the capital, Bordeaux-Aquitaine, also is the reference in a number of key technologies like optics and laser, the science of living environment, and TICs and composite materials. Having for a long time played a major role in international programs, the aeronautics, space and defense industry in Bordeaux represents now over 24,000 jobs. Several companies of the Bordeaux region directly contribute to the Ariane launch vehicle. APAV, present in Guyana since 1974, has taken part in all the deployment phases of the CSG. APAV Guyana, which plays a fundamental role in quality control and risk management, has its management base in Bordeaux, with the headquarters APAV Sud. EADS Launch Vehicles is the Ariane 5 industrial architect. It is also the main stage maker. In the Aquitaine region, it is in charge of the production for the powder acceleration stages. It is also in charge of many subsets such as the high-pressure coiled tanks or heat protections. SNEC Micropulsion Solide produces the nozzles for the solid propellant engines designed based on 60 years of experimentation and innovation in the study of composite materials. The company also provides heat protection elastomers as well as many pressure and temperature sensors. SNPE Matériaux Énergétiques has developed know-how in the field of design, development and production for solid propellant loading. SNP Matériaux Énergétiques places this unique experience in Europe at the service of the space adventure by contributing to the development of boosters for the Ariane 5 launch vehicle. A founding member of the Ariane Towns community, Bordeaux Métropole is particularly proud to be today's sponsor for the Ariane 5 Flight 160.
So back in Jupiter, you can still see we're following the predicted curve, velocity up to almost 4.5 kilometers per second.
Roughly halfway.
Roughly halfway there, and right on target for the predictions.
And on the cursor on the upper left, you see the next milestone, SEP EPC. That'll be separation of the core cryogenic stage coming up in roughly, what, 2.5 minutes?
Correct.
We will be picking up our first downrange tracking station.
Acquisition de la télémesure lanceur par la station de Natal au Brésil.
DDO has just announced that as the tracking station has picked us up, I should say, has picked up the signal emitted by Ariane. This is the tracking station over the border in Brazil at Natal. There are 3 other stations that will pick up the signal as Ariane makes her way across the Atlantic, and we will pass that information along to you when we get it. The Ariane 5 trajectory is designed to ensure that the launcher is always visible from the ground station tracking it. Over now to our second film on our second friends, our group of friends, our Italians at Colifero, who are taking the broadcast tonight. Greetings and good evening to all of you. At Colifero, about an hour outside of Rome, the major players from Italy's space industries and research people are watching the broadcast tonight from the Space Center, from the University of the Mechatronica Engineering, and we hope you are enjoying the broadcast. Ariane Space Flight number 160, Mayor Mario Cattoni here with us tonight.
So still, all is going as expected nominally. We're following the curve, and coming up is SEP EPC, which is the separation of the cryogenic stage.
Now, three things happen, actually. The onboard computer gives 3 commands. One is the cutoff command to stop the engine burning. Then there's a little interval, and there's the command to jettison the stage, and there's a second interval where we will have ignition of the EPS, right? What's the time frame in there?
Between all of those operations is 13 seconds, and so all of this happens very quickly and ensures that we start the EPS burn to continue the mission.
That should be coming up in just about 20 seconds. Director of the Space Center here, Pierre Moskva. A question on the stage separation processes now. It's a series of pyrotechnic cords. Did you want to explain that?
Yes, it's like the fairing, the stage separation is done with pyrotechnic devices, and as you mentioned, the computer sends a command to separate the EPC. We have confirmation that it has separated, and the EPS has ignited. So here's a little animation of what we've just seen. Separation of the EPC, followed by ignition of the EPS.
What happens to the EPC now?
The EPC continues in orbit, but just west of the Galapagos Islands. It will re-enter the atmosphere and makes a turn roughly halfway, 3/4 of the way around the Earth.
And falls into the Pacific again. I imagine there's a little bit of fuel left in there, or is it all completely burnt up?
There's a little bit of fuel in there, but we do vent the tanks, what we call passivizing the tanks, and to ensure that there is no risk of it exploding earlier than planned.
One of the reasons that this site on the Atlantic was chosen as the European space base back in the 60s was, of course, the ability to launch over the ocean and away from densely populated areas.
Correct, correct.
Also, no earthquakes, no threats of hurricanes. The ISRO people, now when they're on the phone, whom are they speaking to?
Well, they're talking probably back to Bangalore and their control center to be prepared to have the satellites picked up. There we have Chris Richmond from Orbital Science, the program manager for this mission, and Tim Hemke, the launch campaign manager from Orbital.
A little smile for the camera.
Yes, both Tim and Rich asked me to say hello to their families who are watching in Dulles, Virginia.
Greetings to all of you. We're about to be picked up by the next tracking station. The DDO has just confirmed that. That's the Ascension Island station. That's the next one. That's a UK island in the middle of the Atlantic, former NASA station, run by cable and wireless.
So there we have, still following the curve as expected. The EPS will burn for another 10 minutes or so.
We want to go to a little 3D animation that will emphasize again the role of the Ariane launcher and the Ariane mission. When the satellites, when the EPC at this point in the trajectory, Ariane's work is not done. There's plenty that's still going on.
Oh yes, the liftoff is just the start of the Ariane space mission. What you're seeing here in this animation is the separations of the satellites. And again, obviously that's our final goal for this mission, to put the satellites in the predicted orbit.
But to do that, Ariane puts them in what they call a transfer orbit. It's not in their final slot.
Correct. We put them to the transfer orbit, and at that point, the satellite teams take over to raise the satellites to their final orbit.
We'll get back to that in between satellite separation, because there's more that Michael will have for you. But for now, we are still in the EPS burn, a rather long burn. We have a little time. We can maybe go to the quiz question. What do you say?
Perfect.
All right. The moment you've all been waiting for, I'm sure, the quiz question for tonight's launch, Flight 160. Question number 160. Here it is. Not counting tonight, of the 15 PanAmSat and Galaxies launched by Ariane, most have been solo flights. By most, I mean 2/3, 10 of the 15, not counting tonight. Galaxy 7, 4, 9, 10R, and 4R, and past 3, 4, 6, and 7. However, on the Indian side, of the 9 ISRO launches that we've done, only 2 have been solo launches. The question, which ones? Again, now you're not going to cheat, Michael, because
No.
Michael has not heard this question, folks. He's going to play along with you. Again, the question, Ariane space flight number 160. Question, of the 9 ISRO launches we've done, only 2 have been single launches. Which ones are they? Now, see if somebody at Bangalore, somebody here can get that. I know it's early in the morning for you out there, but we'll have the answer for you in a moment while you're thinking.
So here we are, still following the curve as predicted. Velocity increasing, 7.8 kilometers per second. Everything on track.
The cursor on the upper left crawling up to, there are 3 milestones coming up, which you'll see. One is the extinction of the EPS, that's the upper stage, and then will be the 2 satellite separations. We're going to go now to a short film on the satellite missions. You'll get some more information on both of our passengers tonight.
This launch will allow us to place on orbit 2 satellites for 2 of our most loyal clients of us, Arianespace, that is PanAmSat, and ISRO. The geostationary transfer orbit parameters have been optimized for this mission to gain some 6 months and more for the 2 satellites.
The INSAT 3A is the biggest satellite built by ISRO, and it weighs around 2,950 kg. This is a combination of a multi-purpose satellite. It has got a communication payload and has got a meteorological payload. The length of the spacecraft, when it deploys, we got a one-sided solar array. The other side, we have the solar sail. So on the 2 east and west, we have the reflector, big reflector of 1.2 meter dia. When all the deployment of the appendages takes place in orbit, the spacecraft, their dimension comes around 7 meter, but in east to west, and 24 meter in north to south. This comes as a support for the INSAT 2E, and the transponder is the high-powered satellite with a high-power TWTA and SSPAs built into the system. This is indigenously developed in India.
My name is Dale Lee. I'm from PanAmSat, and behind me is Galaxy 12, which is the first of 3 satellites built by Orbital Sciences Corporation for PanAmSat. The spacecraft is a Star 2 class satellite. Its coverage is the continental United States, Alaska, and Hawaii. It is designed to work anywhere over the arc of 74 west to 133 degrees west longitude, and it has one gridded reflector to provide video, primarily cable coverage to the United States. It has 24 C-band transponders, and it is a standard 32 for 24 redundancy ring.
We're doing fine, coming up on 8 kilometers per second, almost the speed needed, as Michael said, just under 9 kilometers per second for satellite injection. A little more on our friends at ISRO, the INSAT. The relationship between Ariane and ISRO going back to 1981, which was on the 3rd Ariane launch, where Ariane launched the Apple capsule. Do you remember how much that weighed?
I believe 670 kilos.
That's right on the money, 670. And tonight, satellite is weighing closer to 3 tons. So
the largest satellite launch so far for ISRO.
So you see the evolution of the business over there. Ariane launched 1C in 88 and 2A, B, C, D, and E all through the 90s. And INSAT 3B in March of 2000, that was Flight 128, and 3C in January of last year. So as we say, the 10th launch tonight for our friends at ISRO. The program beginning in 1993, I believe, with the ordering of 1B. There are now 5 INSATs in the fleet.
Correct, 5 INSATs, and we're going to have a little explanation from Dr. Rajangam on the relationships between Arianespace and ISRO and coming to Kourou.
ISRO has got a very long relationship with CSG as well as Arianespace. It started in 1980 when the first Apple was launched in the 3rd experimental flight called LO3. Subsequently, we have been launching satellites regularly. The INSAT 2 series, consisting of 5 satellites of INSAT 2A to 2E, was launched by Ariane here. And subsequently, the INSAT 3 series, we have the 3 satellites so far is being launched. This is the 3rd one in that series. And when we started the campaign, we had a team of 50 people with 6 lady engineers. When we come from India, we find extremely difficult to adapt to this French Guiana because the food habit, the culture, the way of living is totally different. But our people immediately adapt themselves because we know what is the temperament. Nevertheless, the weather is very good here. It is more or less like a typical Indian tropical weather. So weather-wise is not a problem. It's not cold, it's not hot, but only the food habits. So we bring our food and then start cooking and then try to get ourselves adapted to this place, and we are enjoying the hospitality of Arianespace as well as CSG, and some of the people are really happy to be here in a new environment. Thank you.
And thank you, Dr. Rajangandan. A little more on the INSAT 3 series, 3A deriving from the 2 series, especially they say from 2E, a multi-purpose satellite carrying both communication and weather payloads. Now, is that an unusual situation?
That's unusual when we think about direct communication satellites for a communication operator, but for an organization such as ISRO, no, it's not unusual to have 2 different payloads on one satellite. They're able to optimize the services they provide over India.
There is also a solar sail on, I believe it's the north face, and there's solar arrays, but the solar sail is not something that we see with every satellite, I don't think.
No, again, not common on the pure communication satellite, but again, something we've seen in the past from the ISRO organization.
So a little focus on research as well as on corporations and private owned companies tonight with this very interesting and international launch.
We still have about 6 minutes left on the EPS burn, as you can see. We're continuing on the predicted curve, waiting for the extinction of the EPS, and then we go into some maneuvers before the separations.
3A is, I believe, has been mentioned, the third in the INSAT 3 series. Both B and C are in regular service. And I believe we've just been picked up by our final tracking station. There it is, at Malindi over in Kenya. Malindi will see extinction of the EPS, the upper stage, and we'll see both satellite separations. The station was upgraded for the Ariane 5 program, and it is currently operated by the University of Rome. Now, the upper passenger is the INSAT. Now, they are going to be delivered first. We'll get back to this. Over to Dr. Kasturarangan on his organization and space in India.
You know, the Indian Space Research Organization is the premier space agency in India, charged with the responsibility of carrying out the activities related to the use of outer space. Our space program today is primarily driven by the applications needs of the country, particularly with the focus on development at the grassroots level. So in this context, the vantage point of space is used for providing communication support and particularly providing connectivity to distant parts of the country where the communication infrastructure is not that well developed. On the other side, the space systems today are also used for broadcasting. They are broadcasting for the normal television, entertainment, and besides, of course, providing the entertainment, the broadcasting system today is used in the country also for education, for health-related aspects, telehealth, and then what you call as a telemedicine. And then it is also used for developmental communication. So these are all the many dimensions of using the communication satellites. We also have a meteorological component in space, which is used for looking at the weather systems in that part of the world. Very critical for India because India is primarily an agrarian country, and the information on the weather need to be hardly emphasized in this context. Then we have the set of remote sensing satellites. These satellites provide services to optimally manage the resources, which is in great demand because of the population which today exceeds 1 billion. I'm happy to say that India has a very versatile remote sensing constellation used for both land application and ocean applications. In order to meet these objectives and provide a sustainable service to the country, we have developed the corresponding satellites. The INSAT system for multi-purpose communication, broadcasting and meteorology, and an Indian remote sensing satellite system for providing resource sensing from space capability. And on the other side, in order to launch them, we are also in the process of developing the necessary launch vehicle. So we are also building the launch vehicle. We have successfully orbited our remote sensing satellites with our own polar satellite launch vehicle. And we are in the process of also qualifying the geosynchronous satellite launch vehicle, the GSLV. We had a first test flight in April 2001, and we hope to have another test flight in the near future. And that would enable us to evaluate the design of this vehicle, which can put a 2,000 kilogram satellite into a geosynchronous transfer orbit.
Interesting what Dr. Kasturarangan had to say, mentioning that space applications driven by and geared to what each country needs, and in India's case, communications and weather services, an agrarian country.
Correct,
mainly.
correct.
The INSAT is the upper passenger, which means it's going to be injected first. Is there any reason why because it's a heavier satellite? Is that why?
Not necessarily heavier, but volume-wise, the larger satellite. And in the upper position, we have more room for the larger satellites. So INSAT will be injected first, just a little over 3 minutes from now, and Galaxy is inside the Silda, the carrying structure.
So in just
over 1 minute, we'll have the extinction of the EPS. We're at a velocity of 8.4, roughly, kilometers per second.
So we're approaching the magic number?
We're just right on target, exactly as predicted.
You heard the DDO call out the extinction of the upper stage, the EPS. This engine is different than the engine on the lower stage.
Yes, the engine on the lower stage, the Vulcan 1, is a cryogenic engine, much more complicated than the EPS engine.
You can see the cursor moving up towards extinction of EPS, to be followed by the two satellite separations.
Yeah, once we have the extinction of the EPS, we go into what we call the ballistic phase of the launch, where the EPS is not burning, but the maneuvers are still being done to properly orient the two satellites into the final orbit.
This is roughly what it looks like. This is what you call the, as you said, the ballistics phase. Now, when the EPS is no longer burning, we are still moving, of course.
We're still moving, doing the orientations for the correct injection orbit requested by the customer, and showing what, waiting for that injection time, roughly 1.5 minutes for INSAT. Here again, back to the animation, and for this mission, we're using an optimized orbit.
Which means?
Which means we have a little extra performance with this mission, and so we go to a higher perigee and a lower inclination, which gives the two satellites additional life.
Now, this means that Ariane puts the satellites closer to their final orbit on Ariane's power and saving a little bit of the satellite's power, because normally from the transfer orbit to the final orbit, it's the satellite's own power.
Correct. And by saving that additional fuel that doesn't have to be used, the satellites gain station-keeping life, which means the longer life.
Long life predicted for INSAT, roughly 15 years.
So coming up, just about 45 seconds before the separation of INSAT. You see we've stayed on the curve, and the next cross on the curve is the INSAT 3A separation.
In just about 20 seconds. So right now what's going on up there is the composite.
The composite is orientating itself to put INSAT in the orientation specified for this mission.
And then it will spin in another direction to get ready to put the Galaxy in its...
Séparation INSAT 3A.
Okay, you've heard the DDO. Separation of INSAT 3A.
So there's the good news. So congratulations to all of you. Now that INSAT is up, what's going to happen, the Hassan station, that's their master control facility in Karnataka, I hope I'm pronouncing that right, will take control of the satellite just after separation. They should be coming on there now, as it did for 3C and 3B for all orbit raising and in-orbit operations. Then this will be followed by signal picking up at Perth and the stations at Fucino, and in Canada at the Lake Cowichan.
Correct. And here we come now to an interview with Patrick Bongay, Senior Vice President of Programs at Arianespace.
The 514 launch this evening marks the resumption of the Ariane 5 launches after the failure of 517 last December. The weeks that have elapsed since have allowed us to, in fact, study a number of things, starting with consolidation of the technical aspects of the Vulcan 1 engine, with a number of thermal modeling of the mechanical point of view, which have allowed us to get some more margin for the operation of this engine. Besides, the independent committees and reviews have been set up that have studied thoroughly all of the methods and processes that we were applying, and all of these activities have allowed us to start the procedure to fly our commercial launches again, with 2 launches for Ariane 5G to take place in the coming weeks, and which will be followed in the last part of the year by launches of the Ariane 5G Plus launch vehicle, which will bring a number of developments compared with this generic version. Beyond this, the issue that we have had to tackle concerned, on the one hand, the continuity of service for launches, which has led us to recycle a number of launch vehicles, there's Ariane 5 ECA, to transform or to convert them into generic Ariane 5 GS launch vehicles. These launch vehicles will be available right from the middle of next year and will be used for launches in the second half of this year. In parallel, actions for consolidating the Ariane 5 ECA launch vehicle for the Vulcain 2 engine and the upper stage for the cryogenic stage, ECA, will allow us to consider restarting the ECA version of Ariane 5 right from next year, with a version that will be fully consolidated, which will allow us to be back on the commercial market with a battleship that is Ariane 5 ECA with a capacity of dual launches.
So back in Jupiter, just over 6 minutes till the separation of Galaxy 12.
What's going on now?
What's going on now is continued maneuvers and orientation of the remaining composite, which is the EPS, Silda, and Galaxy 12 spacecraft.
And the Silda is what exactly you mentioned? It's sort of a carrying structure.
Yes, it's the carrying structure which allows us to perform the dual launches. INSAT sat on top of the Silda, and as you can see in the animation, protected Galaxy. We have separation of the Silda, so now again, maneuvers to put Galaxy 12 in its final orientation.
The Silda built by Astrium. Now there are different versions of the Silda, I think, no?
Different versions, and depending on the configuration for the dual launch, we can use a slightly larger Silda. Again, it depends on the best configuration to optimize the mission for the customers.
And we're going to be hearing from those customers in just a moment. We're going to be hearing first from Dale Lee, one of the senior managers at PanAmSat. We'll get a little more information on the satellites.
Galaxy 12 is the first of 3 satellites for PanAmSat, which will augment our fleet, providing either replacement capability for existing satellites or in-orbit backup spares in case of any situations, to provide television and cable signals to the United States. They are designed to operate anywhere in the arc, U.S. domestic arc, to provide flexibility and adequate coverage.
So that was Dale Lee giving you some details on the Galaxy 12 spacecraft mission, what the plans are from PanAmSat. And what we'll have coming up next is an interview shown with PanAmSat management, describing and discussing their philosophy for the use of small satellites in today's market, the relationships with Arianespace and Orbital, and the business profile for PanAmSat.
Smaller is better than it's ever been in terms of performance. These next generation satellites provide twice the power that we've had on our previous small satellites, and that's going to allow us to move into bigger and better services for our core video customers. In particular, the extra power is very useful for the higher order modulation that is what makes HD television so successful.
You know, moving forward, there's going to be a lot of opportunities for niche players like Orbital Sciences to make a real impact in the FSS industry. As you're looking at a more rationalization over the next coming of years between the supply and demand curves and the fact that there is limited real estate available in orbit to exploit the slots and bring in additional revenues, small satellites are just a natural solution to moving forward and bringing some rationalization to the industry in general. Arianespace has been our partner from the first launch of a PanAmSat satellite, and that partnership has been strong. We enjoy working with Arianespace. I hope they enjoy working with us. And we're going to continue to work with Arianespace in making their programs a success and PanAmSat's programs a success far into the future. On Orbital Sciences, it really was a very interesting evaluation when we first started looking at Orbital and looking at the unique history that that company has. They started in 1981 providing small payloads and small satellites for primarily military and NASA applications. We ended up selecting Orbital Sciences and moving forward because of the fantastic reliability record that they established over that time period. I remember when we looked at them first back in early 2000, they had completed 87 consecutive launches and satellite deployments with a 100% success record. They had not had a failure in over 4 years.
We think PanAmSat's one of the best managed companies in the business, and we kind of have the results to show it. Actually, I'm getting a little plug in here, if you don't mind, that during a really tough, soft market, you know, we not only met our numbers, but we upgraded our fleet, we really strengthened our marketing program, we built up our backlog. I mean, you know, we had a great year last year. We're having another one this year, and that is in a tough marketplace. So therefore, we kind of tend to gravitate, don't you think, Jim, towards others that we think are well managed.
The PanAmSat and the Orbital people taking the broadcast tonight at the Reagan Center in Washington, D.C.
Also the Orbital facility in Dulles, Virginia.
So greetings to all of you. Orbital, as mentioned in the film, beginning life in 1982, I believe. And this is our fifth launch for them. PanAmSat and Ariane going back to PanAmSat 1, Flight 22 in 1988.
The first Ariane 4?
The first Ariane 4. And all the galaxies through the early 90s. And then the string of the PanAmSats 2, 3, 4, 3R, 6, 7, and 6B through 1999. And then Galaxy 11, 10R, and 4. And then the last satellite to go up in November of 2000, PanAmSat 1R. That was the biggest one, 4.8 tons. So another long and fruitful relationship.
Yes, and 2 more galaxies being built by Orbital to be launched by Arianespace. We're just about 20 seconds from separation of Galaxy 12.
What's the ambience in down there like usually this
Well, right now we're this close, and this is the final separation, so you'll be able to see the joy very shortly. There you go.
There it is. All right. First acquisition will be at Perth, right after separation, right about now, for Galaxy. 4 apogee burns, 2 weeks of testing over to the customer on the 1st of May. Mission accomplished for Ariane. Before we go to the speeches, answer to the quiz. You remember the question? Of the 9 ISRO launches with Ariane, only 2 have been solo. Which ones?
I don't know exactly the numbers, but 2 recent Ariane 4 launches.
2 recent Ariane 4 launchers. You're right on that score. I'll give you 50%.
Okay.
3C and 2E. 3C flight 147, that's recent, January of last year, and 2E flight 117, exactly 4 years ago, on the 2nd of April in '99. I assume because they were the heaviest ones. 3C 2 3/4 tons, and 2E about 2.5. The others roughly 2 tons.
Right, that's a good assumption.
So for all of you, Bangalore or here or anywhere, who guessed the answer to the quiz question, 3C and 2E, your checks and your prizes are in the mail. Congratulations.
So we see the congratulations in the Jupiter control room, and as Joshua said, the mission for this Ariane 5 is complete, but we have the 2 satellites just beginning their missions.
The we're going to go to a replay, I think, while we're waiting for the speeches. We'll be hearing from Jean-Yves Le Gall and from the customers, of course. And we should have 1 or 2, perhaps 3 replays from the different cameras at the different observation sites along the base. So the good news from Kourou is Ariane 5 has once again delivered 2 new satellites beginning life for the Indians and for the Americans. Their services starting up for those customers in just a few short weeks. And as Jean-Yves Le Gall said, lots more Ariane this year. beginning in June. Michael, you're going to be here at your job?
Yes, I'll be back, but first I would just like to say that very nice speeches for two long-standing partners and with Arianespace. But yes, I'll be back here in June for the next launch, but as the RCUA.
So after a letter-perfect countdown with a program hold and a picture-perfect launch, as you can see again, the Ariane 5, of course, has delivered. And the customer is noting Ariane's reputation for technical excellence, which has made its reputation. Well, we hope you've enjoyed the broadcast. On behalf of everybody here at the Space Center, Joshua Jampel with Michael Kaleri.
Good night, Joshua.
Goodbye, everybody.
Nur noch wenige Minuten, dann ist es wieder soweit. Die Wissenschaftler des Potsdamer Geoforschungszentrums öffnen die Dachkuppe und bringen den Laser in Position. Bis zu 5 Mal am Tag schießen sie von hier aus ins All. Das Ziel, ein Satellit. Champ kreist seit über 2 Jahren auf seiner Umlaufbahn. Die Forscher wollen ihn nicht zerstören. An seiner Unterseite ist ein Reflektor angebracht.
Diese kleinen Prismen, diese 4 Prismen, dienen dazu, um das Laserlicht auch über Hunderte und Tausende von Kilometern wieder zur Station zurückzubringen. Und über diese Laufzeitmessung können wir dann die Flugbahn des Satelliten mit Zentimeter- und Millimetergenauigkeit bestimmen.
Diese Daten benutzen die Wissenschaftler, um sich ein genaues Bild der Erde zu machen. So konnten die Potsdamer beweisen, dass die Erde nicht einer Kugel, sondern eher einer Kartoffel gleicht. Solche und auch andere Vermessungen helfen auch beim Hochwasserschutz.
Unser Ziel geht auf die Katastrophenvorsorge, beispielsweise Frühwarnsysteme zu entwickeln oder aber zu simulieren, was bei Hochwassern tatsächlich passiert und dann geeignete Schutzmaßnahmen zu empfehlen. Und wir haben da auch einschlägige Erfahrungen und in manchen Flussgebieten hier in Deutschland auch bereits solche Modellrechnungen durchgeführt, die auch umgesetzt worden sind.
Zum Beispiel in der Gemeinde Adelsheim im Odenwald. Ein sogenanntes 100-jähriges Hochwasser hätte hier einen Schaden von 1,9 Millionen Euro angerichtet. Das konnte im Computer simuliert werden. Durch gezielte Maßnahmen wie die Errichtung von Poldern und Staubecken wurde das Risiko deutlich verringert. Ein Hochwasser mit dem gleichen Ausmaß würde jetzt nur noch einen Schaden von 230.000 Euro verursachen. Neben der Katastrophenvorsorge entwickeln die Wissenschaftler auch Frühwarnsysteme für Vulkanausbrüche und Erdbeben. Die Projekte der Potsdamer sind weltweit verteilt. Und vor der eigenen Haustüre in Schönebeck bei Berlin pumpen die Forscher heißes Wasser aus 4 Kilometer Tiefe an die Erdoberfläche auf der Suche nach der Zukunftsenergie.
Die Wärmeenergie in dem Wasser wird in Strom umgewandelt und das Wasser wird zurück in den Kreislauf, das heißt in die Gesteine wieder hineingepumpt.
Noch ist es nur ein Versuch, aber erste Erfolge gibt es bereits. Wissenschaftler rund um den Globus warten schon gespannt auf diese und andere Ergebnisse, denn bei der Erforschung des Lebensraums Erde sind die Deutschen weltweit führend.
Let me leave you with a star or alternatively, a view from the Hubble telescope celebrating its 30th anniversary. Have a great weekend. Let's check out your weather now elsewhere across the globe. Let's head back to the news desk. Here's Jonathan.
Thanks, Jeremy. I was trying to spot Kazakhstan on the map, and I'll tell you why. The countdown is on to the first human space flight to the International Space Station since the Shuttle Columbia disaster back in February. The Soyuz launch is scheduled for Saturday. Edward Lu of the U.S. and Yuri Malachenko of Russia making up the 2-man crew. They're expected to dock with the space station after a 2-day flight and are scheduled to stay there for about 6 months. The shuttle is due to take off from the Baikonur Cosmodrome in Kazakhstan. CNN will bring you live coverage when it goes up.
Сейчас они закроют, Юра. Закроют.
Так, выходим, выходим. В сторону, чтобы не мешать журналистам. Сейчас все вышли? Нет. Все? Не ломитесь вперед.
Ребята, меня закрыли просто, ребята.
You look back this way when you're done, Ed. There you go.
Все, журналисты, выходите, пожалуйста.
Подальше от ошибок.
Чуть дальше отойдите на метр, и вам легче будет.
Вас, Христов, вам уже встречать придется, выполняя работу. Пусть воскресший Господь поможет вас, укрепит вас в вашей работе. Божье благословение на ваши труды. Богу помоги вас.
Так, все.
Коридор, дайте.
Здорово, я дойду.
Юр, не спеши, Юра.
Ну-ка, отойдите, подальше, отойдите.
Подальше, подальше.
Ну отойди, не толкайся. Фигни. Союз. Владимир Владимирович. Забирайте свои.
Двери. Забирай.
Здоров.
Годен, годен.
Жив? Я тебе сейчас покажу.
Вот сюда.
Да.
Ну, так, прижмись.
Ну что, давайте для кусочек.
Этот, а в скафандре уже вас не видно. Сейчас, пожалуйста.
Спасибо.
Да. Только направо.
Здесь одеваем командира.
Хорошо. Все.
Вальсальва.
Вот здесь, да? All right, can I get you all guys? There we go. Now that's a picture for that. Хорошо. Хорошо. Отлично. Вот здесь московский вариант сейчас. Два.
О, можно? Отлично.
Никто не видит. Email me a copy, would you? One more?
Yeah. Great. Thank you.
It's all kind of the same, isn't it?
Kind of is,
You know?
but then different.
Yeah. Okay, smile at.
Must not have.
Michael, how you doing?
Thanks, Raj.
Теперь переход туда.
Мне нравится полшотный.
Есть 0,1. Доложить давление в скафандре 0,35.
Вы пока выйдете?
Все фотографы ушли все.
Что же они там где? Они в стороне.
Нет, у нас еще 7 минут. 7 минут. Нормально? Хорошо слышите? Слышите хорошо? Да, хорошо. Все в порядке? Скафандр проверили? Вот сейчас подойдет.
Миронов приехал. Как он, председатель федерального
Совета Федерации.
Полицейской федерации. Совет. Вот для Эдуарда это вот третье лицо у нас в России. Третье лицо у нас. Третье лицо.
Ты второе лицо.
Юрий Эдвард, ну я только что прошло заседание Государственной комиссии, все в порядке, никаких замечаний нет. Юрий Павлович вот может подробно еще вас заверить, что ни одного замечания нет, мы готовы и уверены, что все будет в порядке.
То есть я могу заверить, да?
Юрий Эдвард, я только что со старта, там идет работа по заправке, все нормально, замечаний нет, кислородом заправляем и так дальше по графику. Так что вопросов нет. Хорошо.
Как у вас настроение?
Судя по внешнему виду, блестящее.
Ну, я чувствую какое-то волнение, да?
Ну, конечно, есть. Напряжение находится.
Юрий Павлович, было шумно здесь, поскольку у нас был шум от вентилятора. Сейчас у нас другое.
Слушай, он на мире летал, да?
А?
На мире летал?
Да, на мире.
Да, когда были...
Да, вот 4 раза не подошел.
А вот на континенте, когда он доложить, что у нас идет все по плану, Петр Ильич все сказал, у нас никаких вопросов нет. И если у вас нет вопросов к нам, ну, очевидно, мы уже сегодня, вчера переговорили, там, нет вопросов. Так что у нас все идет по плану, и мы надеемся, что все силы приведены в боевую готовность и средства.
вашего стажа тоже ждет. Мы их поздравляли. Здесь недавно на основном мы сказали, что ровно 26-го будет. Но мы так последние все изменения познакомились. Вопросов у вас нет. Им там сложнее сейчас будет, наверное. Они все-таки готовили к спуску к шаттлам, а надо спускаться на Союз, поэтому сейчас они там усиленными темпами изучают документацию. Ну, вы сами понимаете, к вашему полету очень большое внимание в связи со всеми обстоятельствами. Один спустится, пускаем аппарат.
Доброе утро. Я позволю себе так обратиться, потому что имел честь с вами познакомиться 11 апреля в Звездном. Теперь у меня в кабинете календарь с нашей фотографией, с вашими автографами. Я прежде всего хочу вот что вам сказать. Вчера, ровно в 4 часа по московскому времени, я был в Кремле у президента России Владимира Владимировича Путина. И он просил меня вам передать пожелание успешного полета, успешного выполнения всей программы, полученного возвращения обратно. От себя хочу добавить, я хочу просто пожелать, чтобы работа была для вас интересной, чтобы все прошло удачно. Вы не первый раз вдвоем в космосе. Я уверен, что все у вас получится. Удачи, счастливого полета, и мы будем ждать вас обратно. И я надеюсь, что у меня появится еще одна наша совместная фотография с вашей автографией после уже полета. Успехов вам!
Спасибо, Сергей Михайлович. Мы готовы к полету и хорошее настроение, и тоже есть уверенность, что все будет нормально, и выполним всю программу.
Спасибо, удачи, ребят.
Уважаемые друзья, связанная с той ситуацией, которая сложилась, но я думаю, и ваш предшествующий опыт, и, будем говорить, понимание всей той ответственности и значимости этого полета воодушевят вас на осуществление нормальной такой экспедиции. Мы все с нетерпением будем ждать вашего возвращения, уверены, что все получится и нам будет сопутствовать удача. Добра и счастья вам в полете. Пожалуйста.
Пожелать счастливого старта, успешной работы и знаете, что мы вас ждем на земле.
Спасибо большое за пожелания.
Спасибо, Юра.
Ну, я думаю, вы 40-летний Валентина Владимировна ответите на борту. Мы будем ждать репортаж. Договорились?
Спасибо.
Как настроение? Не холодно? Нет? Нет. Ну, подруга твоя ждет здесь, смотрит на тебя, так что все будет в порядке. Ну и Майк поддерживает, так что все.
Ну, вы хорошо понимаете, сейчас вам несколько будет сложнее. Раньше вы 3 человека работали на орбите, а вам придется эту экспедицию 2 человека. То есть вся тяжесть вот на 2 человека. Вам придется немножко посложнее. Но я думаю, что мы в октябре месяце все это возобновим. И там будет попроще. Но вся тяжесть вот сегодня, в таком переходном периоде, конечно, ложится на вас. На Россию само собой, но на Юрия Николаевича, сколько не грузил, все равно вывезет. Нам немножко тяжеловато.
Самый мощный носитель.
Так вот, постарайтесь. Вопросы? У вас, если нет вопросов, то мы просто еще раз вам желаем счастливого полета, старта, страховки. И в обязательном порядке передайте ребятам. Им тоже не просто.
Юра, но после старта мы родителям позвоним. Так что телефоны есть, все нормально. Ну что? Чего?
У вас есть там по графику времени?
Генерал Костель, директор программы «Шаттл», программы
For a job well done in training, and I think as you both know, this is a very critical time for the International Space Station. We're very proud of both of you and very pleased to have this team going up and to take care of things and to work through a lot of the issues that are remaining. So on behalf of NASA, we wish you all the best success on your on-orbit task. You have a very strong team on the ground supporting you here and with the partners behind you. So we wish you all the best in your flight. Congratulations.
Thanks a lot. Ну, я думаю, к вашему возвращению мы его к русскому подучим.
Во-первых, замечательную работу, которую вы проделали во время подготовки. Пожелать вам всего наилучшего, прекрасного, успешного полета. И хотим заверить вас, что на Земле остается очень большая, дружная и хорошая группа людей. И вот рядом ваши дублеры, которые находятся рядом с вами, которые сделают все возможное для того, чтобы обеспечить успешное выполнение этого полета. Еще раз от имени НАСА разрешите поблагодарить вас за отличную работу и пожелать вам успешного полета.
Знаками показываем, что вы можете вставать, и мы тоже.
Ну что, еще раз, ребята, удачи, не волнуйтесь.
Мы вас встретим на стартовой позиции, сейчас вы будете там на той государственной комиссии официально. На стартовой позиции там вас нет. Если
ребятам привет передавайте.
Юра, помашите сюда, пожалуйста.
закрывай, там больше никого не должно быть.
Удачи. Один кадр. А у меня как раз.
Well, good morning and good evening, everyone. This is Mission Control Houston. You're watching live a Russian Soyuz rocket ready to launch the 7th expedition crew to the International Space Station. Soyuz, which is the Russian word meaning union, is a little more than 53 minutes away from being launched on a trajectory that will take cosmonaut Yuri Malenchenko and astronaut Ed Lu to their home for the next 6 months. Launch is set to occur at 10:54 p.m. Central Time or 9:54 a.m. local Saturday at the Baikonur Cosmodrome in southern Kazakhstan. 1,300 kilometers southeast of Moscow, Baikonur is home to many historic launch pads and is a sprawling complex that measures about 60 miles by 47 miles or 95 by 75 kilometers. By comparison, NASA's Kennedy Space Center in Florida stretches 34 miles or 54 kilometers from north to south and 10 miles or about 16 kilometers across. When including the adjoining Cape Canaveral Air Force Station, another 25 square miles of property can be added. Earlier this morning, the Expedition 7 crew began its quest to join with the International Space Station by leaving its hotel about 3:39 this afternoon Central Time. And Baikonur, that's about 2:39 a.m. Moscow is about 2 hours later than Baikonur. About 4:39 this morning is when the crew departed its hotel in preparation for the suit-up. One of the traditions is for the two crew members to sign the door, basically autograph the door to their hotel before they head out. Again, this occurring in the wee hours at Baikonur. Again, about 3:39 this afternoon is when the crew began its final departure point from the hotel. They head from the Cosmonauts Hotel for the assembly and test building at the Cosmodrome there at Baikonur. They there have their small breakfast and then their final physical checkup. They also, one of the traditions is for the two crew members, again, Yuri Malenchenko and Ed Lu, to have a final blessing. And that blessing here, footage, again, with this occurring much earlier this morning at Baikonur time. Again, tradition reigns supreme in Russia and for all space launches. The two crew members here now departing the hotel. Next stop for the two crew members, Ed Lu there on the left and Yuri Malenchenko now heading off to board a bus that takes them to their suit-up room. Again, some of the same activities you see with a shuttle crew that launches from the Kennedy Space Center in Florida as well. Lou and Malenchenko now arriving again much earlier this morning in Baikonur, this afternoon East Coast time, undergoing the final physical checkups before beginning the suit up. The actual suit up began about 6:30 this afternoon, this evening Central Time. Ed Lou from Honolulu, considers Honolulu and Webster, New York, his hometowns. He was born in 1963 in Springfield, Massachusetts. He's heading to space for the third time, having flown twice previously on STS-84 in May of 1997, which was the sixth shuttle mission that docked with the Russian space station Mir, and also flew coincidentally with Malenchenko as a mission specialist on STS-106. He and Malenchenko conducted a spacewalk during Atlantis' mission to the International Space Station. So both of these crew members have been to the International Space Station previously, but they are going to see a much larger complex when they arrive 2 days from now. Again, the crew's suit up began about 6:30 this evening Central Time. And it's about a half an hour to an hour long process to climb into their spacesuits before heading out to the launch complex. Ed Lou on his launch and landing suit, wearing a patch of STS-107, the crew of Columbia, that was lost on February 1st. Ed Lou has a PhD in applied physics from Stanford University. He also holds a commercial pilot certificate. He actually has more than 1,200 hours of flight time. On his two previous space flights, he's accumulated more than 500 hours of time in space.
Только направо.
Ed Lou will be serving as the flight engineer and also the NASA International Space Station Science Officer for Expedition 7. 6-month voyage beginning tonight and ending with the next Soyuz arrival to the station in October of this year. Johnson Space Center Director General Jefferson Davis Howell. Also Chief of the Astronaut Office Kent Rominger there on the left.
О, можно? Отлично. Никто не видит.
And astronaut Bob Cabana is head of the Flight Crew Operations Directorate at the Johnson Space Center.
It's all kind of the same, isn't it?
And Yuri Malenchenko there now donning his spacesuit. Malenchenko, born in 1961 in Svetlovodsk, the Ukraine, graduated from public schools there, and in 1983 received a pilot engineer's diploma from a military aviation school. Then in 1993 he graduated from the Zhukovsky Air Force Engineering Academy. He's flown twice in space previously as a crew member on STS-106. He commanded Mir 16. And there they are, Yuri Malenchenko on the left, Ed Lu on the right, going through their final suit checks prior to departing for the launch pad. After completing the suit up, the crew members completed their final briefing by the State Commission. And that occurred a little after 7 o'clock Central Time. And then they headed out of the Assembly and Test Building about 7:45 and then headed out to the launch pad. They arrived at the launch pad a little after 8 o'clock this evening Central Time and began climbing aboard the Soyuz rocket at 8:15. And just a short while ago, cabin leak checks were underway, those occurring at 9:30 this evening Central Time.
Раз, два, три, четыре. Раз, два, три, четыре.
And we're now 42 minutes, 30 seconds from launch of Expedition 7 aboard the Soyuz rocket. The Soyuz capsule was mated to its booster 3 days ago, and the Soyuz rocket was transported by rail car to launch pad at dawn on Thursday. Here we see some of the mating process and the initial steps of the rocket being rolled out of its assembly building. The rocket took a short trip of about an hour to the launch pad, and after reaching the pad, it was hoisted into a vertical position in preparation for tonight's launch. The rocket with the capsule housed inside a protective shroud at the top stands 162 feet tall, which is about 49 meters, and weighs 683,400 pounds at liftoff. The launch complex is known as Site 254 and is the very pad that's been used for every crewed launch from Baikonur, including that of the first human to be sent into space, Yuri Gagarin, 42 years ago this month. Once in space, Malenchenko and Lu will oversee the conduct of several orbital correction burns using thrusters on the Soyuz to adjust its altitude in relation to that of the International Space Station. They are just some of the steps the two will perform at the outset of their journey in space. Their first task, however, is to learn everything they can about the station from the current crew, Expedition 6 Commander Ken Bowersox, Flight Engineer and Soyuz Commander Nikolai Budarin, and NASA ISS Science Officer Don Pettit. This crew rotation via Soyuz spacecraft is dictated by the loss of Columbia and the temporary hiatus of space shuttle flights to the ISS. Following a 6-day handover, Expedition 6 is ready to return home after 5.5 months in space.
Since the 6th expedition to the International Space Station was scheduled to last just 3.5 months, the crew members were eager to get started once they arrived on orbit. Commander Ken Bowersox, Flight Engineer Nikolai Budarin, and NASA ISS Science Officer Don Pettit officially took over from the Expedition 5 crew just hours after coming on board November 25th. 7 days later, they said goodbye to the crew of Endeavour and kicked off their mission of scientific research. A majority of the experiments during the mission involved learning more about how the body responds to long periods in weightlessness, which will be the case on future missions to Mars and beyond the solar system. All 3 crew members participated in a study of how lung function is affected in zero-G, and were subjects in a study of how well a dose of potassium citrate reduces the chances of developing kidney stones. Several times during the flight, Bowersox wore an instrumented suit throughout the day, gathering readings that scientists believe will help them understand more precisely how people actually use their arms and legs while they're weightless. And through a comparison of pre-flight and post-flight physical examinations of the expedition crew members, researchers will try to learn what effect the spaceflight environment has on human bones and muscles. Early on in the mission, Science Officer Pettit, who is a chemical engineer by training and an inquisitive mind by nature, began taking advantage of the zero-gravity environment in his free time to demonstrate scientific principles. He videotaped the experiments and called it Saturday Morning Science.
Let's see what happens now when this effervescent antacid tablet is added to the sphere of liquid. The water will chemically react with the effervescent antacid tablet and produce bubbles of carbon dioxide gas. And these bubbles will form on the surface of the antacid tablet, and that presents a heterogeneous system where the bubbles can be popped off the surface with some momentum. And of course, what we're seeing here is the salvation to zero-gravity heartburn.
In mid-January, Bowersox and Pettit conducted the 50th spacewalk in support of ISS assembly, spending almost 7 hours outside the station to complete several jobs, including the release of launch restraints to deploy the photovoltaic radiator from the aft side of the P-1 truss, and cleaning debris from the sealing ring on the Unity node's nadir docking port. As they passed 2 months on orbit, the station crew got a chance to talk to some old friends who happened to be in the neighborhood. 4 of the astronauts on board Space Shuttle Columbia, who were just days away from the end of their mission. 5 days later, Columbia and its crew were lost. The course of Expedition 6 was about to change. The crew spoke about the accident a few days afterward.
Well, the folks on the ground have been real good about reducing our schedule, and we've had time to grieve our friends, and that was very important. When you're up here this long, you can't just bottle up your emotions and focus all the time. I mean, it's important for us to acknowledge that the people on STS-107 were our friends, that we had a connection with them, and that we feel their loss. We sat in by radio on the memorial service that was held at the Johnson Space Center. And at the conclusion of that memorial service, after the bells had rung on the ground and the T-38s had flown by, it was very quiet on board, and we rang our ship bell 7 times. And at that point, it was very, very quiet on board the International Space Station. But now it's time to move forward, and we're doing that slowly. This press conference today is a huge step that's helping us move along towards our normal objectives and fulfilling our mission here.
The ton of food, clothing, fuel, and other material in the Progress supply ship that arrived in early February assured that the expedition crew would remain supplied into the summer. Meanwhile, they made thorough audits of what supplies were actually on board, while mission managers considered the options for future resupply and crew rotation while the Space Shuttle fleet was grounded. The station crew kicked off a new field of science research when they brought the Microgravity Sciences glove box back to operation. 2 power controller boxes for MSG that had failed near the end of Expedition 5 and were brought back to Earth for repair along with that crew, had been returned to ISS on the Progress supply ship. Pettit installed the parts in the glove box, which houses microgravity science experiments involving potentially hazardous fluids or flames, and worked with payload controllers over several weeks to bring MSG back to full operation. During this time and throughout the mission, all 3 crew members used their cameras to pursue another area of research. From the vantage point of more than 240 miles up, they took film and digital still photos and videotape of planet Earth, documenting surface changes caused by the inhabitants and gathering unique views of some familiar landmarks and coastlines. In late February, Bowersox and Pettit conducted an important practical exercise to prove that just 2 astronauts can get themselves into and out of the spacesuits used for spacewalks out of the Quest airlock, and do it without the help of a 3rd crew member. Just days later, the space station partners announced that the next station crew would include just 2 people to lower the demand for supplies while delivery to the station by space shuttles was temporarily halted. That they would launch on the Russian Soyuz spacecraft scheduled for late April, and that the Expedition 6 crew members would come home in May on board the Soyuz already docked to the station, making Bowersox and Pettit the first American astronauts to ever land in a Soyuz. They continued with their science and the routine maintenance of their home on orbit, and in early April, the Expedition 6 crew wrapped up some maintenance work during an unscheduled spacewalk, reducing the likelihood that the 2-man Expedition 7 crew would have to leave the station during their tour of duty. With Budarin again monitoring activity from inside ISS, Bowersox and Pettit reconfigured power for the control moment gyroscopes, replaced a power controller on the mobile transporter, and won a lasting place in the heart of every amateur do-it-yourselfer on Earth. When a light stanchion on the S1 truss would not deploy as planned, they used a hammer to make it comply. Nearing 5 months on orbit, Bowersox, Budarin, and Pettit started packing for the trip home and brushing up on their training for operations of the Soyuz TMA spacecraft, for becoming the first expedition crew to finish their flight on the steppes of Southwest Asia rather than the marshes of coastal Florida.
We're now 32 minutes and 45 seconds away from launch of the Soyuz from the Baikonur Cosmodrome, carrying the Expedition 7 crew to its home for the next 6 months aboard the International Space Station. Some of the milestones in the final hours of today's countdown have included activation of the Soyuz booster's internal systems for final health checks. That includes the module's radio communications system, the thermal control system, and the motion control system to provide stability for Soyuz once in orbit. About 3 hours ago, the 3 stages of the Soyuz rocket were loaded with propellant, which has been replenished and topped off during the past 2 hours. Thanks, Rob. Rob Navius on the scene at Baikonur. We're now 28 minutes, 30 seconds from launch of the Soyuz rocket carrying Expedition 7 to the International Space Station. The crew suited up again about 6:30 this evening Central Time and began climbing aboard the Soyuz rocket about 8:15 p.m. Central through a hatch on the side of the TMA capsule. Their capsule is high above the 3 stages of the Soyuz booster, which are all liquid-fueled with kerosene as their propellant. The first stage has 4 liquid rocket engines strapped to the side of the core vehicle. Each one of those has a single engine with 4 main chambers and 2 gimbaled vernier thrusters providing 3-axis flight control. Combined with the core engine, these 4 strap-on boosters will burn for approximately 1 minute 58 seconds. The core engine serves as the second stage and continues to burn until about the 4 minute 58 second point. A single engine powers the core vehicle with 4 vernier thrusters providing 3-axis flight control after the first stage boosters have separated. The third stage has a single engine that will burn for about 4 minutes 2 seconds, shutting down at about the 9-minute mark after launch. Once the final stage has completed its job, the Soyuz spacecraft will be in an initial orbit of 145 miles at its high point and 113 miles at its low point. That's 233 by 182 kilometers. Additional engine firings will occur over the course of the next 2 days to place the Soyuz at an altitude closely matching that of the International Space Station. Now just under 27 minutes from launch. The 23.5-foot-long Soyuz TMA spacecraft weighs 15,800 pounds and is composed of 3 modules. At the top, the orbital module, at the bottom, the instrumentation propulsion module, and sandwiched in between, the descent module in which the crew resides. The newest version of the Soyuz capsule, known as TMA for Augmented Transportation Module, better accommodates the range of sizes represented by the Corps of Astronauts and Cosmonauts. Individuals as large as 6 feet 3 inches tall and 209 pounds can fly on the TMA, compared to 6 feet and 187 pounds on the earlier TM, used since May of 1986. Minimum crew member size for the TMA is 4 feet 11 inches and 110 pounds, compared to 5 feet 4 inches and 123 pounds for the TM. Once deployed after reaching orbit, the spacecraft's solar array wings span nearly 35 feet. The entire spacecraft is cocooned at the top of the rocket by a shroud, which is jettisoned about 3 minutes after launch. The crew uses the orbital module during on-orbit operations. It includes the docking mechanism, the hatch, and the rendezvous antennae. The TMA configuration has 2 new engines, which reduce landing speed and the forces felt by crew members by about 15 to 30%. A new entry control system and 3-axis accelerometer also increases landing accuracy. Instrumentation improvements include a colored glass cockpit, which is easier to use and gives the crew more telemetry. This portion of the Soyuz separates from the remaining compartments only after the deorbit burn has been completed near the end of the spacecraft's mission. It burns up harmlessly in the Earth's atmosphere. The descent module contains personally contoured couches for the crew members during launch, re-entry, and landing. This module contains all controls and displays necessary for critical flight activities. It also contains life support provisions, batteries for the re-entry and landing, as well as the parachutes and landing retrograde rocket engines. The instrumentation propulsion module actually is made up of 3 smaller compartments: intermediate, instrumentation, and propulsion. The intermediate compartment basically provides the structural attachment to the crew compartment. It houses the oxygen storage tanks, attitude control thrusters, avionics, and communications and control equipment. The instrumentation compartment houses all avionics equipment used for primary guidance, navigation, and control, and computer systems for the entire spacecraft. It is a sealed pressure vessel containing nitrogen gas used to circulate and cool all of the equipment. The propulsion compartment performs all orbital maneuvers, including those needed for rendezvous with the International Space Station and the deorbit burn at the end of the spacecraft's mission. Its propellants are nitrogen tetroxide and unsymmetric dimethylhydrazine, which also fuel the reaction control system that provides attitude control throughout the orbital phase of flight. 2 solar arrays linked to rechargeable batteries are launched folded against the body of the Soyuz. A number of antennae and other sensors are located on the exterior of the instrumentation propulsion module and on the solar arrays themselves. This compartment separates from the descent module after the deorbit burn and burns up harmlessly in the Earth's atmosphere, just like the orbital module. The entire capsule not only will serve as a crew transport vehicle to and from the International Space Station, but it also will remain docked to the station for 6 months, acting as an emergency return vehicle in the event the crew should have to leave the station unexpectedly. About 40 minutes ago, updates to the Soyuz's onboard computers were sent in pre-programmed commands, and just about 20 minutes ago, launch officials initiated a timing device which governs the final major events leading to the Soyuz's launch at 10:54 tonight Central Time, or 9:54 a.m. Saturday Baikonur time. The Soyuz rocket is manufactured in the Russian town of Samara, while the Soyuz capsule is built and tested at Rocket Space Corporation Energia facilities near the Russian Mission Control Center in Korolyov. This type of launch vehicle is quite versatile, having been used in various configurations to launch satellites since 1963. Its first use as a crew transport was in 1967.
After years of preparation for the flight, Expedition 7's Yuri Malenchenko and Ed Lu start the last leg of their journey to the International Space Station from the Baikonur Cosmodrome in the Southwest Asian nation of Kazakhstan, from the same launch pad where Yuri Gagarin made the first human spaceflight more than 40 years ago. They're flying in the latest version of Russia's venerable Soyuz spacecraft, the Soyuz TMA, which also serves as the lifeboat for space station crews. Like the previous version, the Soyuz TM, there are 3 modules to a TMA. The center component, the descent module, is the spacecraft's flight deck, where the crew members will be strapped in during launch and again for landing. Part of the upgrade in this Soyuz are modifications that permit both larger and smaller crew members than before. That means more NASA astronauts now meet the physical requirements for assignment to station crews. During the 2-day flight to the station, the Soyuz crew has access to the orbital module, or habitation module, which was originally designed as a prototype space station. The 2 modules have a combined living space of less than 400 cubic feet. The instrumentation and service module contains the propulsion, guidance and navigation, and power systems of the Soyuz spacecraft. Commander Yuri Malenchenko rode to orbit in a Soyuz in 1994 and made his second trip to space on a space shuttle.
I can say that launch on the shuttle and on Soyuz are more or less the same. Maybe it is a little bit more smooth on Soyuz, fewer vibrations.
While he's not the first American to launch in a Soyuz, Ed Lu's flight does have a significant difference as compared to the Soyuz flights of American astronauts Norm Thagard and Bill Shepard.
What'll be different is the fact that I'll be riding as the left seater, i.e. the board engineer or the co-pilot, and that means a whole lot more than riding in the right seat, which is essentially the passenger seat.
The board engineer is responsible for maintaining all systems on the Soyuz and assisting the commander when needed. The journey from the launch pad to the station takes 2 days.
The starting orbit will be at an altitude of 120 kilometers, and then we will lift it to the station altitude, which is 400 kilometers. So we will be busy building our own attitude so that we can dock to the station at a certain altitude, a certain attitude, and orientation.
The 2 days on orbit also allows the crew members to become acclimated to being weightless before they perform the critical docking tasks. Wearing their launch and entry suits, called Sokol suits, Malenchenko and Lu work closely with the Russian flight control specialists in Moscow as the Kurs automated rendezvous and docking system guides Soyuz to a link-up with ISS at the nadir port of the Zarya control module. 1 orbit later, after pressure and leak checks confirm a tight seal between the Soyuz and the station, Malenchenko and Lu open the hatch and enter their new home on orbit. The new crew's scheduled to spend 6 days, taking a handover from Expedition 6 Commander Ken Bowersox and flight engineers Nikolai Budarin and Don Pettit before they board the Soyuz TMA, which arrived at the station last fall for the trip back to Earth, leaving Expedition 7 to start a mission that's scheduled to last into October.
Back at the launch site at the Baikonur Cosmodrome, the Soyuz stands ready for launch as continuous checks are made of its systems. We're at 18 minutes, 6 seconds and counting to launch. Liftoff is set for 53 minutes, 51 seconds after the hour. Launch is precisely timed so that the crew can rendezvous and dock with the International Space Station 2 days from now. At the time of today's launch, the International Space Station will be off the southern tip of South America, northwest of the Falkland Islands. Officials have conducted additional checks of the Soyuz's onboard batteries, having just completed a realignment of the rocket's trajectory control system. In a few minutes, Soyuz's telemetry systems will be activated and monitoring of its thermal systems begins. 10 minutes prior to launch, the Soyuz's steering jets will be activated as well. During the climb to orbit, tracking and telemetry is provided through systems in the second and third stages. These two stages have their own radar transponders for ground tracking via individual telemetry transmitters. Vehicle health status is downlinked to ground stations along the flight path and is routed to the Mission Control Center in Korolyov outside Moscow. There, flight controllers are ready to begin monitoring the Soyuz following its launch and insertion into orbit. Energia conducts oversight of the Russian modules of the International Space Station. Those are Zarya, Zvezda, and Pirs, while flight controllers here in Houston watch over the U.S. segment comprised of Unity, Destiny, and Quest, along with the powerful solar arrays generating electricity for the nearly 200-ton complex. A group of U.S. controllers known as the Houston Support Group in Moscow are led by Mike Boggs and Adam Baker and are joined by veteran NASA Flight Director Joel Montalbano and Canadian astronaut Chris Hadfield, who has recently been certified as a Soyuz flight engineer at the Gagarin Cosmonaut Training Center outside Moscow. The HSG, as the group is known, interfaces with its Russian counterparts to bridge the two centers for cohesive real-time operations. Back here in Houston, the International Space Station Flight Control Room at NASA's Johnson Space Center, a team of about 20 flight controllers is watching over the ISS in conjunction with their counterparts in Moscow. The team today is actually using the shuttle flight control room since some upgrades are being made down the hall to the ISS flight control room. The station is at present at an altitude of 250 miles as it travels over the southern portions of the Pacific Ocean, heading on a southeasterly track that will take it over the southern tip of South America in just a few minutes. When Commander Yuri Malenchenko and flight engineer Ed Liu lift off, the station will be traveling again just off that southern tip of South America. In preparation for this launch, the Expedition 6 crew aboard the ISS since late November 2002, along with U.S. and Russian flight controllers, has been readying the station for its new crew by performing a dress rehearsal of the docking, by thoroughly testing procedures and systems as required. This crew will wake up in about 2 hours and 20 minutes to prepare for its next day on orbit. The station's orientation or attitude was altered to match what will be required for the docking Monday with this new crew arrival. The ISS is ready for the arrival of the newest Soyuz spacecraft. While the mood in Mission Control is very businesslike, it also is one of excitement as this team watches over the orbiting complex 24 hours a day, 7 days a week, 365 days a year. Overseeing activities here are ISS flight directors Derek Hassman and Matt Abbott. They have direct contact with their Russian shift flight director Igor Topol in Moscow and are joined by an experienced team of flight controllers that includes Ginger Carrick, who is serving as the communications interface between this team and the Expedition 6 crew presently on board the station. She is joined by Vladimir Sokolovsky. He is the Expedition 6 and Expedition 7 Soyuz crew training coordinator. He's here tonight as a consultant to the team. The present configuration of the International Space Station includes 6 pressurized modules, as mentioned a few minutes ago: Zarya, Zvezda, Unity, Destiny, Quest, and Pirs. They combine to provide 15,000 cubic feet of pressurized volume, which doesn't include the small Progress supply craft and the current Soyuz crew vehicle docked at the complex. Additional critical elements to the station's operation are these huge solar arrays which generate electricity for the outpost and its ongoing experiments, and a 130-foot-long railroad to remotely maneuver equipment along with the Canadian Space Agency provided robotic arm called Canadarm2. The station's current dimensions are 171 feet long, 240 feet wide, and 90 feet high, with a total mass in space of 397,780 pounds, or about 180,000 kilograms. We're now at 12 minutes, 50 seconds and counting to the launch of the Soyuz capsule and the Expedition 7 crew from the Baikonur Cosmodrome in southern Kazakhstan. For Russian and American flight controllers, the next 2 days will be spent watching over the rendezvous of the Soyuz with the International Space Station, leading to the docking scheduled to occur just before 1 a.m. Central Time Monday. That docking, followed 90 minutes later by the opening of hatches into the station, marks the start of a 6-day shift change or handover between the two crews. Again, the countdown continuing to proceed on schedule, with launch just 12 minutes from now. Ground controllers at Baikonur are sending commands to activate the telemetry system, which will relay vibration and acoustic data to the American and Russian flight control teams in Korolyov during the Soyuz's ascent. The crew has been aboard the Soyuz capsule for about 2 hours now, conducting final systems check with Russian launch controllers. It's an experienced crew led by a veteran Russian cosmonaut, teamed with a NASA astronaut, combining for 4 previous space missions and nearly 160 days in orbit.
The 7th expedition to the International Space Station is composed of just 2 crew members as a way to reduce the demand for supplies while the space shuttle fleet remains grounded. Commander Yuri Malenchenko and NASA ISS science officer Ed Lu are both spaceflight veterans who've been involved in the ISS program for years, and they weren't fazed by the changes that were required for their flight.
The fact that we are together and that it's an international project allows us to continue this effort. We have the capabilities of different countries that we can put together to continue.
Yuri Ivanovich Malenchenko, a colonel in Russia's Air Force, is a veteran cosmonaut and space station commander. He was born and raised in the town of Svetlovodsk in central Ukraine. After graduating from the public schools there, he spent a year studying radio electronics before beginning his studies at military aviation school and moving toward his childhood goal.
At the beginning, I wanted to have a profession which would not be boring. I wanted something dynamic, something ever-changing and challenging. At one point, I wanted to be a sailor. Later in my life, I wanted to be a pilot. And I think my dreams came true because I was a military pilot. I was in the Russian Air Force.
4 years into his Air Force career, Malenchenko was approached about joining the Cosmonaut Corps. He trained at the Gagarin Cosmonaut Training Center in Star City for 7 years before commanding the Mir 16 mission in 1994. During that 125-day flight, Malenchenko conducted 2 spacewalks and completed the first ever manual docking of a Progress supply ship to the Russian space station when the automatic docking system failed. Malenchenko made his first trip to ISS in 2000 on the space shuttle flight that outfitted the Zvezda service module, and he made the spacewalk to complete the external cable connections on Zvezda. His EVA partner that day? Ed Lu, now his flight engineer and NASA ISS science officer on Expedition 7. Lou is excited at the prospect of flying a mission that has not been planned out down to the minute.
I actually think that this increment has the potential to be much more challenging than the original version of this increment, simply because of the fact that we don't know what we're going to be doing. There's many more unknowns now, and that's part of the fun of it.
Lou was born in Springfield, Massachusetts, and grew up in Webster, New York, near Rochester. With a bachelor's degree in electrical engineering from Cornell University and a doctorate in applied physics from Stanford, he began his career as a researcher in solar physics and astrophysics, working at laboratories in Colorado and Hawaii. Lou says he never thought of trying to become an astronaut until a friend who was applying to NASA urged him to do so.
About a year and a half later, I got a phone call saying, hey, do you want to come on down for an interview? And that's how I ended up here. It wasn't some sort of preordained thing where I had been planning it my whole life.
Lou's first space shuttle mission was a 1997 trip to exchange American crew members on board Russia's Mir space station. 3 years later, he and Malenchenko and their STS-106 crewmates were the first people to enter the Zvezda service module on orbit during the mission to set it up for the arrival of the first expedition crew. Despite the variation in their professional backgrounds, the Expedition 7 crew members share similarities that are as simple as 1, 2, 3. They're on the first 2-man crew on ISS, on their second visit to the International Space Station, on the 3rd space voyage of their careers.
Welcome to those just joining NASA Television's live coverage of the launch of the 7th expedition crew atop a Soyuz rocket from the Baikonur Cosmodrome in Kazakhstan. The weather conditions at launch today are partly cloudy with temperature expected to be 57 degrees Fahrenheit at the time of launch. Engineers continue to monitor all systems aboard the Soyuz rocket and its Soyuz TMA capsule, set to begin its voyage to space in about 7 minutes. The official launch time is 10:54 tonight Central Time, or 9:54 a.m. Saturday local in Baikonur. We're now looking at a live picture also inside the capsule. Ed Lu, the flight engineer, on the right side of this picture, and Commander Yuri Malenchenko on the left as they look over their checklist during these final minutes to count to the launch. A few minutes ago, commands were sent to switch power from ground sources to Soyuz's onboard batteries. Soon after the Soyuz reaches orbit, its command and control system will be activated, and stored computer commands will deploy communications antennae. The first will be the Coors rendezvous and docking antenna, which will be used to provide automatic range rate information on its final approach to docking with the Zarya control module's nadir, or Earth-facing docking port. Presently docked to other ports on the station are the Progress resupply craft to the Zvezda living quarters' aft docking location to the far left in this picture, and the Soyuz TMA crew module docked to the Pirs module. It will deliver the Expedition 6 crew home on May 3rd. Shortly after reaching orbit tonight, the Soyuz's solar arrays will be deployed, stretching to a wingspan of 35 feet or 10 meters. They will collect solar power for use by batteries to generate electricity for equipment on board. About 90 minutes into its new life in space, the crew aboard the Soyuz will continue its programmed activation sequence as it makes its first pass over Russian ground stations. Systems activation will begin in rapid succession, including the module's power supply system, its radio communication system, and the critical motion control system. Later tomorrow, the motion control system will establish a stable orientation for the Soyuz as it continues its 2-day chase to rendezvous with the International Space Station. On the launch pad at Baikonur, the countdown is proceeding on schedule, now just 5 minutes from the launch of the Soyuz rocket. At this point in the countdown, the Soyuz's first stage steering jets are in the ready-to-launch position, and ground commands have been received from the rocket indicating that all control and auxiliary systems are ready for launch. We're at T-minus 4 minutes 35 seconds and counting. The launch control reports that the range at Baikonur is clear, and the Soyuz rocket is ready to begin its journey. The onboard systems have switched to onboard control, and the Expedition and Soyuz commander Yuri Malenchenko's controls have been activated. Crew members close their helmets at this time, and they also put them on suit oxygen and prepare the launch key as it is inserted into the launch bunker, ready for launch. Now, just under 4 minutes from launch, all systems still go for launch for the Soyuz rocket, again ready to begin its journey to catch up with the International Space Station 2 days from now, with docking just before 1 a.m. on Monday Central Time. As the Expedition 7 crew of Yuri Malenchenko on the left in this picture, and flight engineer Ed Lu, astronaut, on the right, as they prepare for their journey aboard the International Space Station, Expedition 6 is about 2 hours away from starting its day, its 155th day in space. The crew actually is currently at in its 154th day on orbit since becoming a station crew after being delivered to the International Space Station on STS-113 back in November. So they'll be concluding a 5.5-month voyage in space after their 6-day handover with this crew, now 3 minutes from launch.
Purging, second stage, copy.
The nitrogen purge of the engine combustion chambers is underway on board the Soyuz rocket. And next up is the pressurization of the booster tank for flight. We're now at T-minus 2 minutes 30 seconds to launch. All systems still go for launch this evening. Again, launch set for 53 minutes, 51 seconds after the hour. All indications are a very smooth countdown to launch. The clouds have broken up over the launch pad, and all looks good for launch. Now 2 minutes from launch.
This is a CNN live event.
Welcome. We're now looking at live pictures of the Soyuz mission expected to take off from Baikonur, Kazakhstan just moments from now. And joining us there from Baikonur, Kazakhstan is CNN's Jill Doherty. Jill, what's the scene like over there?
Well, Manita, the wind-swept plain out here in Kazakhstan as the moment draws closer. The weather is very good. It's been clearing. It was overcast, but now it's clearing. A lot of people here, military and civilians, looking expectantly. They have binoculars, waiting for the moment that this is going to take off.
All right, Jill, thank you very much for this. And joining us here at the set is Norm Thagard. Thank you very much for being with us. And you're a retired astronaut. What can you tell us? What's going through the minds of the astronauts right now? And we can see inside the cabin.
Well, we can see inside the cabin. And they're probably, if they're thinking about anything, because this is a pretty exciting time, reviewing the things that they've got to do in the coming minutes. But you can see in the scene, you've got the Russian commander in the center seat and Ed Lu, the American astronaut, who now has to serve for the first time as the flight engineer for the flight in that on the right side, the left side of the capsule.
Lots of expectations on this mission.
Absolutely, because it is, of course, the first flight since the Columbia.
Right. And because this is a two-man crew as opposed to a three-man crew, what are the, I guess, the hindering factors to that?
The main factor for the on-orbit phase of it is that third person who normally would be devoted primarily to science won't be available, so much of the science that might have been planned will have to be put in abeyance for future time.
So what basically will they be doing?
They'll be responsible for keeping that station operating. Even though it's a fairly new station, it still does require some routine maintenance, and things will always fail, and they're there to take care of those things.
And of course, they'll be relieving the three other astronauts who are up there, two American and one cosmonaut.
Exactly.
Who have been there up there since, I believe, November, and they'll be arriving May 4th. It'll be a very emotional return for them as well. It will be, because in effect, they're in a new regime, they're in a new era, and it's happened while they were in orbit. And of course, they're isolated, so they didn't get a lot of nuances of what was going on. Okay, we're seeing the launch.
Journey in space to continue the permanent human occupancy of the International Space Station.
The video is live because the in-camera view is possible to transmit throughout the whole of ASCENT.
We have a good report of a roll and pitch program, according to flight controllers, as the Soyuz begins to streak toward a rendezvous with the International Space Station.
Feeling well. Parameters of structure of the launch vehicle are in order. 40 seconds. Catalyzation is stable.
Good first stage performance. The Soyuz delivering 102 tons of thrust from its 4 boosters and single engine. The first stage of the Soyuz measuring 68 feet in length, 24 feet in diameter. It burns for about 2 minutes, 6 seconds of the flight.
That's amazing stuff. And they're talking about the Soyuz. This is like a, I guess, a new and improved
already traveling 1,100 miles per hour,
if you will.
It is a slightly improved and modified carrier from the one that took me up in 1995. And if you saw some of the external video of the rocket, you would have seen TMA. When I flew, it said TM. The A designates the fact that this is a newer version.
And the newer version would, as we look inside the cabin right now, the newer version is roomier in the sense that it would allow for a third person, right?
Actually, that was a capability before. I think the major part of the modifications was an upgrade in the computer systems on board. There actually is a third seat on the very bottom of the screen on the left, and ordinarily if that seat were occupied, the person in that seat would be changing this view from time to time to get at the camera on the other side looking across at him.
Coming up on 1 minute, 50
and
seconds.
Let's bring in Jill Doherty, who is in Baikonur, Kazakhstan. And Jill, how important is this mission for Russia right now?
120 seconds.
Well, it's important, I think you'd have to say, Monita, in terms of really showing that the Russians still can do what they do best and really what they started. You know, when you're out here and you see Baikonur and you realize the history that is here, the Russians, the first people into space, and the history, this stand, the launching pad, in fact, is the Gagarin launching pad, Yuri Gagarin. And famous people have been put into space from this place, and I think you'd have to say that the Russians, the pride does come out. And another thing, Monita, that I wanted to tell you is when you're standing here, I've never been as close as this, and you feel it through your entire body. It's an amazing experience. Just the thrust of those engines literally shake everything as it goes up in that blinding flash of light. But it's actually almost a gentle lifting. It doesn't go up quickly. I was surprised at that. It almost lifts gently and then out and disappeared in the clouds.
That's amazing stuff. Jill Doherty reporting to us there from Baikonur, Kazakhstan, watching the liftoff of the Soyuz carrier there. This is a lot of hope and expectations riding on this mission, as it's the first one since the disaster, the Columbia tragedy there back in February. They will be relieving 3 astronauts, Kenneth Bowersox, Donald Pettit, and cosmonaut Nikolai Budarin, who have been up in space since November. This will be a 2-man crew, and as you say, while science will not be conducted, a lot of experiments will not be conducted, they are serving a very, very important mission.
Absolutely, it's important, I think, to keep the station well maintained during this period of time.
And not only, but also because of the expectations or hopes for the International Space Station in general.
Exactly. I think we need to continue to show a commitment to this sort of adventure.
All right. Thank you very much, sir, for being with us. Norm Thagard there, and Jill Doherty in Baikonur, Kazakhstan. The news continues. I'm Monita Rajpal, and you're watching CNN.
Pressurization in progress. Copy.
Now 1 minute, 20 seconds from launch. The Soyuz is now on internal power, and the automatic launch sequencer is on. Now less than 1 minute to launch. "45 seconds and counting. Less than a minute away from launch of the 7th expedition crew, and only the 3rd American astronaut to ride a Soyuz into orbit.
Copy.
30 seconds from launch.
Start.
The launch tower is now beginning to be moved away from the vehicle. 10 seconds from launch. First stage engines should be at flight speed. 3, 2, 1.
Start.
Have engine start and liftoff. Liftoff of the Soyuz, beginning cosmonaut Yuri Malenchenko and astronaut Ed Lu's 6-month journey in space to continue the permanent human occupancy of the International Space Station. We have a good report of a roll and pitch program according to flight controllers as the Soyuz begins to streak toward a rendezvous with the International Space Station.
Feeling well. Parameters of structure of the launch vehicle are in order. 40 seconds. Catalyzation is stable.
Good first stage performance. The Soyuz delivering 102 tons of thrust from its 4 boosters and single engine. The first stage of the Soyuz measuring 68 feet in length, 24 feet in diameter. It burns for about 2 minutes, 6 seconds of the flight.
80 seconds.
Ed Lu on the right, Yuri Malenchenko on the left, on their way to join their colleagues in space at the International Space Station.
Control, 90 seconds. Thrusters of the second and the first stages nominal, 100 seconds. Launch vehicle structure parameters are nominal, 110 seconds.
Coming up on 1 minute, 50 seconds into the flight. Standing by for the jettison of the 4 strap-on boosters.
120 seconds. First jettison.
The rescue capsule atop the Soyuz rocket has been jettisoned.
Is nominal, 140 seconds. Parameters of the launch vehicle are nominal, 150 seconds.
And as we hear, all is nominal now, 2 minutes, 30 seconds into the flight. Soyuz is traveling about 3,300 miles an hour, about 1,500 meters per second.
Jettison. Copy. Jettison of the shroud.
The launch shroud around the top of the rocket has been jettisoned, now approaching 3 minutes into the flight. Soyuz now traveling 4,700 miles per hour.
190 seconds. Launch vehicle structural parameters are in order. 200 seconds.
3 minutes, 20 seconds into the flight, the Soyuz's second stage is performing as advertised. The second stage of the Soyuz is 56 feet in length, 13.5 feet in diameter, with a single engine providing 96 tons of thrust for its 3 minutes and 28 seconds of operation.
Nominal. 220 seconds. Nominal flight. Everything is in order on board. 230 seconds. Stabilization of the unit is nominal. 240 seconds.
Ed Lu on the right, Yuri Malenchenko on the left, on their way to the station. Ed Lu, the 3rd American astronaut, heading to space aboard a Soyuz rocket. The first being Norm Thagard to the space station Mir, the second being Bill Shepard, the Expedition 1 commander, to the International Space Station.
Structural parameters of the launch vehicle are nominal.
All continuing to go smoothly as we hear 4 minutes, 30 seconds into the flight.
Control system parameters of the launch vehicle nominal.
Standing by for the burnout of the core booster engine and separation, which occurs at about an altitude of 105 miles.
Separation of the second stage. 300 seconds.
5 minutes into the flight, the second stage has completed its job for the day. It's now dropping away from the rocket. About 4 minutes of powered flight remaining.
Stabilization of the unit, nominal.
The Soyuz is now being propelled by the single engine of its 3rd stage, the engine providing 30 tons of thrust, and again it will burn for about 4 minutes and 2 seconds total. All continuing to go smoothly, 5 minutes, 30 seconds into the flight.
Thrusters of the 3rd stage are operating nominally. 340 seconds. Control system parameters are nominal. Copy. 350.
6 minutes into the flight, Ed Lu, Yuri Malenchenko on their way to space for their third missions each. This one being a long one, 6 months, with their mission to the International Space Station to last until October when the next Soyuz arrives to bring them home and bring the Expedition 8 crew to the station as their replacements.
The thrusters of the third stage are operating nominally.
As we hear, the third stage performance is nominal. The Russian word normalna we hear periodically. Now 6 minutes, 35 seconds into the flight.
400, stabilization of the unit, nominal. 410 seconds, nominal flight. 420. Coordination parameters and rotation. Nominal. Thrusters nominal. 440. Stabilization nominal. Nominal flight.
Seven minutes, 40 seconds into the flight. Velocity is now 13,500 miles per hour.
Structural parameters nominal.
All again continuing to go smoothly in the delivery of Expedition 7 to space to prepare for a rendezvous and docking with the International Space Station in the wee hours Monday. The International Space Station traveling northeasterly across the central Atlantic Ocean.
.490. Stabilization of the unit nominal.
8 minutes, 20 seconds into the flight. It's a little less than a minute now remaining in powered flight. Once the third stage delivers the Soyuz to orbit and the module is separated, a series of pre-programmed commands will be executed to prepare it for orbital operations.
520.
The stored commands are called time-tagged commands, and they allow many of the Soyuz's systems to be automatically activated by onboard computers at precise times that are stored in those onboard computers.
Activation, yeah.
9 minutes into the flight, we have confirmation of cutoff of the third stage.
Third stage.
Ed Lu's fiancee, Christine Romero, there in the foreground of that picture. Johnson Space Center Director General Jefferson Davis Howell on the far right. Standing by to get confirmation of the Soyuz successful launch, which now 9.5 minutes into its mission.
Stage is and we wish you luck. This is 16.3. How do you read me? Very well. This is 16.3.
A beautiful launch beginning the Expedition 7's mission, a 6-month voyage into space. Now that the third stage has completed its mission, it's performing an avoidance maneuver by opening outgassing valves in its liquid oxygen tank.
Andre, by the way. And hello, we are congratulating you. We are joining our colleagues in greeting you. We've seen you, we've heard you. Everything seemed to be on time. All indicators were nominal. Separation indicators were nominal. RPV 1 and 2 got closed in time. We have no issues on our
All went very smoothly with the launch occurring on time at 53 minutes 51 seconds after the hour.
Raise your visors in about...
Next up for the crew is the automatic deployment of antennae and solar array deploy on the spacecraft. And we do have confirmation that the solar arrays have deployed on the Soyuz's spacecraft.
We got pressure here. I'm not actually reading you, but I can see 824, 824. In the habitation, 8 module 824. Well, just thank you. Just tell me something. Are you feeling well? Oh, yes. We are doing great. Well, we cannot hear you very well, though. Well, same here.
Crew busily going through checklist, a post-insertion type checklist.
Well, we hope that next compass will hear you much better.
The Soyuz at an altitude of 145 miles by 113 miles. The International Space Station, by comparison, is at an altitude of about 250 miles. So with the Soyuz an initial orbit below the station, it will allow the Soyuz to, over the course of the next day and a half, to basically catch up with the station. Over the course of that time, a series of rendezvous maneuvers, rendezvous burns, will be conducted to systematically and slowly raise the Soyuz's orbit to closely match that of the station for the final approach and docking, again set for the wee hours Monday. The docking actually scheduled for 12:56 a.m. Central Time. That's just before 2 a.m. Monday, East Coast time.
Let's record the next compass 0825 47.
Now that the Soyuz spacecraft is in orbit, control of it from here on out will be overseen from the control facility in Korolyov, which is just outside Moscow, the location for the Russian Mission Control Center. "14 minutes into its mission.
Come again. If all the pressurization parameters are fine, you can go ahead and...
We're continuing to watch Expedition 7 as they can now, that they're safely in orbit, raise their visors. Ed Lu there on the right. American astronaut on his third voyage into space. Yuri Malenchenko, his third voyage as a cosmonaut into space. The two actually flew as crew members on STS-106, shuttle mission to the International Space Station in its fledgling stage. They conducted a spacewalk together on that flight.
Comlink. We'll do that.
Warm welcome back to you. The Russian and U.S. manned Soyuz spacecraft is on its way to the International Space Station after taking off from Kazakhstan just a few minutes ago. Retired astronaut Norm Thagard joins us now right here on more on the launch and the importance of it. And Mr. Thagard, there's a lot of hope, a lot of expectations for this mission, isn't there?
Well, Anita, there has to be, because it is the first flight after the Columbia tragedy, and it is the first opportunity that we have had to replace the crew that's already been there for the 6-month lifespan of their Soyuz spacecraft.
And what's also interesting is that not only is this a two-man crew, they are on a Russian Soyuz spacecraft.
They are, and of course the expectation was most of these flights would, for crew changeouts, would be done via the space shuttle, and now that's had to change with the grounding of the fleet.
Now, the Soyuz in itself was usually kept as just a reserve safety vehicle, was it not?
For the International Space Station, that's true, but of course until the shuttle started going up to the Mir station a few years ago, they kept their own Salyut and Mir space stations solely resupplied with Soyuz and Progress vehicles.
And because this is just, what, barely 2 months after the Columbia disaster, a lot of questions now and about the track record, the safety record of the Soyuz. It's been a good track record, would you not say?
I'd say it's been extraordinarily good. They did lose 2, both of them on entry, one when a chute failed and another when they had a valve open and the cabin depressurized, but overall it's been extraordinarily successful.
Let's talk a little bit about this mission in itself and what exactly will this two-man crew be doing? I mean, are there hindering factors of the fact that there aren't 3 people involved?
There are, and one of the things they won't be doing a lot of, but I think they can probably do some, is the science, because ordinarily with 3 people, 2 would be devoted to keeping the station in good working order, and the 3rd person would be more or less full-time available for conductive science experiments.
In terms of the importance of this mission, we were talking about the hope and expectations of it. Because it's the first one since the Columbia tragedy, they are, I guess, the hopes that the International Space Station must go on, that the experiments that do take place are indeed crucial.
They are, and you're always at risk if you leave the station with no crew on board, because if something goes wrong, there are things that only a crew actually physically there could correct. No one wants to take that chance, and that is the reason, in fact, that they're going to go ahead and send a replacement crew up.
While the 2 of them are up there, what exactly will they be doing, and how long will they be up there? Because they won't be able to conduct the science and the experiments.
Well, I think they'll probably do some science, but greatly limited. But even if you could do a lot of science, you'd still be restricted so long as you're supplying the station with the Soyuz, because it has such a very limited capability to either take things up and even a less capability to bring them back.
Let's talk about Russia's capability in terms of holding this responsibility.
I am proud of the Russians for stepping forward. They've had economic problems generally in their society for a while. Specifically, the space program has suffered from the economic depression, but they've stepped up to the plate. They're saying, yes, we will supply the Soyuz and the Progress vehicles necessary to keep a crew on board the International Space Station. It's a good sign.
And of course, they will be bringing back, the Soyuz will be bringing back 3 astronauts.
It has to, because their Soyuz, their lifeboat, is nearing the end of its guaranteed lifetime. So it'll soon go out of warranty, and they don't want that to happen.
Okay. Norm Thagard, thank you for being with us. We appreciate it.
My pleasure.
Soyuz-Rakete zur internationalen Raumstation ISS gestartet. Sie hob um 5:54 Uhr mitteleuropäischer Sommerzeit vom Raumfahrtzentrum Baikonur in Kasachstan ab. Der Amerikaner Lu und der Russe Malenchenko werden 6 Monate an Bord der ISS verbringen. Ursprünglich sollten die Astronauten mit der Atlantis zur ISS fliegen. Nach der Columbia-Tragödie vor 3 Monaten hatte die NASA jedoch alle Flüge abgesagt.
Of the International Space Station will soon be able to return home. A replacement crew is on the way after taking off from Kazakhstan on Saturday. CNN's Miles O'Brien has more on their mission.
Launch. It was not the spacecraft, not the place, not the mission they bargained for. And yet it still went off with no discernible flaws.
Have engine start and lift off.
NASA astronaut Ed Lu and Russian cosmonaut Yuri Malenchenko lofted to orbit atop a blazing Soyuz rocket from the launch pad where human space travel began 42 years ago this month. They were slated to fly on the space shuttle Atlantis, and then the Columbia broke apart over Texas on February 1st.
It was a great tragedy. And immediately it became clear that everything will change from this moment.
Instead of building, they will be tending, keeping the lights on and the dream alive.
It's going to be more of a challenge, obviously, but I think we'll have a really good time with it. That's our plan.
NASA's plan is to rely on the Russians to provide transportation to and from the International Space Station while the shuttle fleet is grounded. The venerable Soyuz spacecraft will tote the crews. Unmanned Progress supply ships will carry the freight. It is a lot to ask of the cash-strapped Russians, but no one likes the alternative, mothballing the orbiting outpost.
Nobody likes to have a ship or an airplane or even a car that's sitting for a long period of time without being operated. It's just not good for the machinery.
But it will be a scaled-down effort. Crew size is capped at 2 instead of 3, and the spacefarers will have to conserve their supplies, particularly water, which is brought up by the bagful on space shuttles.
No one ever promised that the whole experience was going to be living in a luxury hotel, and the original mission wasn't either. I mean, the space station is not meant as to be living in a five-star hotel.
They will greet the outgoing residents of Hotel Space Station on Monday. Astronauts Ken Bowersox and Don Pettit and cosmonaut Nikolai Budarin will return to Earth a week later after showing the ropes to their relief. For NASA, the safe launch is a big relief. And for the Russians, once seen as unreliable partners in the space station project, it is vindication. Miles O'Brien, CNN.
Im Absturz der US-Raumfähre Columbia ist wieder eine bemannte Weltraummission ins All gestartet. Eine Soyuz-Trägerrakete hob vom kasachischen Weltraumbahnhof Baikonur ab. Der russische Kosmonaut Malenchenko und sein amerikanischer Kollege Lu sollen die bisherige Besatzung der internationalen Raumstation ISS ablösen. Russland hat dafür die Soyuz-Kapsel zur Verfügung gestellt, weil die US-Raumfahrtbehörde NASA wegen der Columbia-Katastrophe ihre Shuttleflüge bis auf Weiteres gestrichen hat.
Soyuz craft is carrying a Russian cosmonaut and an American astronaut. The two will relieve the crew on board the International Space Station, who've been there since November.
Liftoff for Soyuz and the start of a two-day journey up to the International Space Station. With all US shuttles grounded, this now is the only way to get there. On board, US astronaut Edward Lu and co-pilot Yuri Malenchenko. They'll spend 2 days in this capsule. Back on the ground at Russian Mission Control, there was relief that the launch had been successful and confidence that the International Space Station program was back on track.
I can tell you that we have a safe mission, a mission that's going to continue science, and a mission that will continue a manned presence on board the ISS space station. And that's a tribute to the robustness of the ISS partnership.
Before the flight, a very Russian experience for the American astronauts. First, a traditional blessing from an Orthodox priest. Then, a struggle with a Russian spacesuit. Edward Lu is the first American to fly into space since the Columbia shuttle disaster. He says he's dedicating this voyage to the memory of Columbia's crew. Steve Rosenberg, BBC News, Moscow.
It's the anniversary of the world's worst nuclear accident at Chernobyl. The Ukrainians have been honoring the thousands of people who died when one of its nuclear reactors exploded. And 17 years later, Chernobyl continues to pose a threat.
In the village where many of Chernobyl's workers lived, they came to mourn the thousands who died and the millions who were made sick. They lost friends, colleagues and loved ones when at 1:23 on the morning of April 26, 1986, the number 4 reactor at Chernobyl exploded.
The fate of the people in the pictures here was a tragic one. They are our friends and comrades we worked with. We were lucky we survived.
In the Ukrainian capital of Kiev, President Leonid Kuchma led a ceremony to remember the 4,500 of his countrymen who were killed in the explosion and cleanup operation. Now it's emerged from declassified secret police and KGB files that Chernobyl had a history of malfunctions and safety violations throughout the 70s and 80s, including a radiation leak in 1982. Yet, on the very day of that terrible accident, a report was sent to Moscow saying the situation at the plant was under control. 7 million people have suffered physical or psychological effects from the radiation, with nearly 2.5 million sufferers in the Ukraine alone. And the legacy of Chernobyl continues. The concrete sarcophagus built to contain the reactor was intended to last 5 years. Now the Russian Atomic Energy Minister is warning it's in danger of collapsing, risking yet another radiation leak from Chernobyl. Alison Griffiths, BBC News.
You're watching BBC World.
Erstmals seit dem Columbia-Absturz ist wieder eine bemannte Rakete in den Weltraum geflogen. Die russische Sojus startete am Morgen vom Raumfahrtzentrum Baikonur. An Bord sind ein Amerikaner und ein Russe. Die Sojus-Crew soll die Besatzung der internationalen Raumstation ISS ablösen.
Seit das Space Shuttle Columbia vor knapp 3 Monaten abstürzte, ist wieder eine bemannte Mission ins All gestartet. Vom russischen Weltraumbahnhof Baikonur hob am Morgen eine Sojus-Rakete ab. Der Flug dient nicht nur der Wissenschaft, auch die Werbung hat den Reiz der Schwerelosigkeit für ihre Produkte entdeckt. Philipp Trunk.
Gerade mal 2 Astronauten sind an Bord der Sojus, als die Rakete am Morgen in Baikonur abhebt. 2 Astronauten und 10.000 sächsische Käsemilben. Die kleinen Tierchen produzieren Würchwitzer Milbenkäse. Die Spezialität soll nun im All Weltruhm erlangen und die Astronauten dürfen sich am speziellen Geschmack erfreuen.
Wie so ein ganz alter Käse, Schweizer Käse, der so vielleicht 15 Jahre alt ist. Also wenn er richtig alt ist, braucht man nur ganz wenig auf die Schnitte zerlegen und schon hat man einen intensiven Geschmack. Und das wäre ja wichtig für die Kosmonauten, da oben alles geschmacklos ist.
Käse hin oder her, die Astronauten sind im Nebenberuf längst zu fliegenden Litwassäulen geworden. Bei einer Geschwindigkeit von 28.000 Stundenkilometern kommt auch Feinripp aus Sachsen zur Aufführung. Der Unterwäschehersteller Bruno Banani gab seine neueste Kollektion mit auf die Reise. Und selbst Techno-CDs verkaufen sich anscheinend besser mit der entsprechenden Weltraumwerbung. Für die notorisch klammen Russen sind die Reklameauftritte längst eine wichtige Einnahmequelle geworden. Ob Pizza aus Amerika oder Milch aus Israel, für 14.000 € die Minute wird alles verspeist. Und für manchen Produzenten geht im All ein Traum in Erfüllung. Zurück auf der Erde soll jedenfalls entschieden werden, ob der Würchwitzer Milbenkäse als Weltraumnahrung taugt.
Da sind wir gespannt.
Zur Weltpolitik. Nächste Woche wird George Bush voraussichtlich das Ende des Irakkriegs verkünden. Fotowirksam auf einem US-Flugzeugträger. Von einem Sieg wird er nicht reden, heißt es aus Washington, denn wesentliche Ziele seien noch nicht erreicht. Und wie, um das zu illustrieren, wird Bagdad heute von Explosionen in einem Munitionsdepot erschüttert. Mindestens 6 Menschen sterben. Das US-Militär sagt, es sei angegriffen worden. Noch ist Bagdad also alles andere als befriedet.
Es war der Super-GAU. Aus heiterem Himmel schlugen die Raketen mitten im Wohngebiet ein. 6 umliegende Häuser wurden fast vollständig zerstört. Die gewaltigen Detonationen waren bis ins 15 Kilometer entfernte Bagdad zu hören. Ich wurde aus dem Bett geschleudert. 1 Stunde lang hagelte es auf uns nieder, Schlag auf Schlag. Ich dachte, wir müssen alle sterben. Im riesigen Waffenlager der irakischen Armee sollen sich mindestens 80 Raketen und mehrere Millionen Schuss Munition befunden haben. Die US-Einheit, die das Lager entsorgen sollte, wurde nach eigenen Angaben von Unbekannten angegriffen. Erst feuerte jemand 4 Leuchtraketen auf uns ab, direkt ins Waffendepot. Das Feuer löste die Explosionen aus. Wir haben das Lager verlassen und als wir wiederkamen, wurde noch aus Handfeuerwaffen auf uns geschossen. Die Bilanz ist verheerend. 6 Mitglieder einer Familie kamen bei der Explosion ums Leben. Nach Vermissten wird noch gesucht. Mehr als 20 Menschen wurden zum Teil schwer verletzt. An einen Angriff mag von den Anwohnern niemand glauben. Seit einer Woche zerstören die Amerikaner hier täglich Munition, obwohl wir dagegen protestiert haben. Das sei vollkommen sicher, haben sie gesagt. Der Vorort von Bagdad war im Krieg weitgehend verschont geblieben. Empörung und Wut über die sinnlosen Opfer sind nun groß. Die US-Armee hat den Familien ihre Anteilnahme für den tragischen Verlust ausgesprochen.
Luc Walpott in Bagdad, ein Munitionsdepot so nah an Wohngebieten. Haben die Iraker recht, die den Amerikanern Unvorsichtigkeit vorwerfen?
Ja, das haben sie ganz sicher. Auf der anderen Seite muss man einfach sagen, es war ein Munitionsdepot, das seit Jahren dort war und auch nicht von der amerikanischen Armee eingerichtet wurde, sondern eben ein irakisches Depot war. Die Amerikaner haben das weiter genutzt, um teilweise Munition, die sie in den umliegenden Dörfern aufgesammelt haben, dorthin zu bringen. Es sollte alles dann von da aus an einen weiteren sicheren Ort kommen und entsorgt werden. Aber soweit ist es nun mal nicht gekommen. Sicherlich kann man den Vorwurf machen. Andererseits, es liegt, und das sagte der amerikanische Offizier auch im Interview, es liegt einfach in dieser Stadt überall an jeder Ecke Munition herum. Es ist unglaublich, in welchem Ausmaß hier Munition sichergestellt werden muss.
Die Amerikaner sagen, sie seien angegriffen worden. Wer sind denn die Kräfte, die in dieser Stadt die Amerikaner noch angreifen, und wie stark schätzt man die ein?
Nun, wenn die Darstellung der Amerikaner stimmt, dann ist das natürlich höchst bedenklich, denn es gibt ja nicht nur eines dieser Waffenlager, dieser Munitionsdepots, es gibt eine ganze Menge davon rund um die Stadt herum. Und das heißt, ein solcher Vorfall könnte sich leicht noch einmal ereignen. Aber es hat schon in den vergangenen Tagen einige Flugblätter gegeben, die hier kursierten, wo mit Anschlägen auf die amerikanischen Besatzungstruppen gedroht wurde, auch auf Jay Garner, auf den Zivilverwalter, den die Amerikaner hier einsetzen. Man muss mit solchen Anschlägen rechnen. Sie kommen aus den möglichen oder unmöglichen Ecken. Es können Reste des Saddam-Regimes sein, Fedayeen-Kämpfer, die sich als Guerilla jetzt verdingen wollen, oder auch aus der religiösen Ecke. Man weiß es nicht. Bislang hat sich niemand zu solchen Anschlägen bekannt.
Die bemannte Raumfahrt geht weiter. Zum ersten Mal seit dem Columbia-Unglück vor 3 Monaten sind heute wieder Astronauten zur internationalen Raumstation ISS gestartet. Ursprünglich hatten der Amerikaner Lou und der Russe Malenchenko dabei eine US-Raumfähre benutzen sollen. Aber dann strich die NASA bis auf weiteres alle geplanten Flüge und die Russen sprangen mit einer Sojus-Kapsel ein.
Atem anhalten in Baikonur. Auch wenn die routinierten russischen Raumfahrer es nicht zugeben, vor diesem Start waren alle nervös. Doch die Sojus-Rakete hebt präzise ab. Wenig später melden die Kosmonauten, planmäßige Umlaufbahn erreicht. Ihr könnt die Helme aufmachen, heißt es nach 7 Minuten. Der Flug verläuft normal. Der Russe Malenchenko und der Amerikaner Lou fliegen nur zu zweit. Der 3. Platz in der Kapsel ist mit Proviant und Gerät vollgepackt, da die US-Shuttles im Moment ausfallen. Und die Erinnerung an die getöteten Columbia-Astronauten ist immer dabei. Wir tun das, was Sie auch gewollt hätten, sagt Edward Lou vor dem Start. Wir fliegen weiter ins All und beenden die Mission, die Sie angefangen haben. Die Russen gewährleisten nun, dass die Raumstation nicht verwaist. Gebannt verfolgen die Familien der Kosmonauten den Start in Baikonur. Applaus, als die Kapsel die sichere Umlaufbahn erreicht. Ich bin so erleichtert, ich konnte kaum hingucken und doch war es das Beeindruckendste, was ich je gesehen habe, sagt die Verlobte von Edward Lou. Am Montag, wenn alles nach Plan verläuft, wird die Sojus an die internationale Raumstation andocken.